Let's start in. In this session, we are going to discuss Amazon S3. So Amazon S3 is a store, retrieve any amount of data from anywhere. So it means Amazon S3 is a storage service. Amazon S3 is a storage service. Yeah. Let's understand what are we are going to cover as part of Amazon S3. First, we are going to understand Amazon S3 introduction, like what is Amazon S3, features of Amazon S3, why Amazon S3, advantages of Amazon S3, and we are going to discuss what are prerequisites for Amazon S3. Then once we understand Amazon S3 introduction, we are going to start discussing creating bucket. What is bucket? How to create a bucket? Inside a bucket, we can create folders, we can upload files. How to create folder? How to upload files? How to upload folder from your local file system to S3 bucket? How to delete a file? How to delete a folder? How to delete a bucket? So complete a practical we are going to see. Once we understand this process of bucket, folder, file, then we are going to understand very important topic Amazon S3 storage classes. There are multiple storage classes in AWS S3 for reducing cost. What is the default storage class? Why we use that default storage class? If you want to reduce storage cost, what are different classes are available? What is the purpose of each storage class? How can we select different storage classes for my file or my bucket or my folder? How we can select? So with the practical examples, we are going to see storage classes. Next one, very important one, AWS S3 versioning. Let's say this is my bucket, bucket B1. In this B1, I created folder F1. In this folder F1, I uploaded file called sales, sales dot CSV. Let's say today I uploaded, tomorrow also I uploaded, day after tomorrow also I uploaded, same location, same file. If I upload any file, what happens? It will override old file with new file. It will override with new file. Let's say first day one file, let's say we have 1 GB. Day two file we have 10 GB. Day three file we have 15 GB. Day four file we have only 10 MB. Unexpectedly or unknowingly, someone uploaded just MBs of file into this S3 bucket. What happened? This smaller file override your bigger file, then we lose the data. But my company is asking, uh, they want a bigger file that is 15 GB data file. Assume we removed from local file system also. After uploading, we removed all files from local file system because AWS S3 providing 100% reliability. So no need of maintaining local file system. That's why those people deleted. But they want that larger file. How? How can we resolve? So to resolve such kind of problems, we can enable versioning. We can enable versioning. So if you upload every time, it will maintain different versions, version 1, version 2, version 3. Let's say my company wants to previous version data, that is 15 GB data. Then you can go versioning location, you can select a particular version, you can download, you can re-upload. You can re-upload. Then we cannot lose old data. So versioning allows us to maintain different versions of your data. If required, whatever the version you want, you can recover. That is the main advantage of versioning. So we are going to discuss what is versioning, how to enable versioning, how to download particular version, how to re-upload. We are going to see with the practical examples. And then we are going to discuss AWS S3 life cycle management. What is the life cycle management? How to set life cycle management? With the practical example, we are going to see. Once we complete this one, we are going to see encryption and security in AWS S3. By default, by default, S3 side, we have a server side encryption. So AWS S3 provides different algorithms to encrypt your data. How we can select a encryption for AWS S3? What is server-side encryption? What are different encryption algorithms are available? How to encrypt data into S3? We are going to see with a practical example. Once we complete this one, we are going to see AWS S3 integration with Python. We use Boto3 API. We, we are going to integrate AWS S3 with Python. And then we are going to discuss different uh, different AWS S3 examples too. So these are the concepts we are going to cover as part of Amazon S3. Yeah, let's continue it. As part of Amazon S3, let's understand what is AWS S3 and what are key features of AWS S3. AWS S3, AWS S3 is a first service in AWS. They invented AWS S3 is a first service in AWS Cloud. AWS Cloud. AWS S3 is a storage service. AWS S3 is a storage service. Storage service. And full form of S3. Simple storage service. Yes, yes, yes. Repeated 3 times. That's why they are calling S3. Simple storage service. Yes, yes, and yes. S3. S3 full form is simple storage service. It is a storage service in AWS S3. It is a storage service in AWS S3. It allows to store any amount of data. There is no limitation for AWS S3. It supports multiple types of data. It supports multiple types of data. It is not a particular type of data. You can store images, you can store videos, you can store documents, you can store logs, you can store Backup data, you can store CSV, JSON, XML, Parquet, Avro. You can store any type of data into AWS S3 and any size of data. There is no limit to store data into S3. What are main features of S3 is highly secure. Highly secure. First one, we can achieve security using first important service in AWS is IAM. IAM full form is identity and access management. Let's say we created a user. If user want to access this S3, if you created user in AWS, then if that user want access, he need a IAM permission. Without IAM permission, user cannot access. Second one, we can encrypt the data, we can store the data. We have server-side encryption. You can implement your own uh, client-side encryption to provide security for your data. And next one thing, it is highly fault tolerant. Highly fault tolerant. You never lose data until unless you override. If you override also, you can maintain multiple versions of copies so that you never lose data. It is highly fault tolerant. At any time, you can access S3 data. And and it supports unlimited storage. It supports unlimited storage with pay as you go basis. S3 S3 comes with comes with free tier, free tier. Under free tier, let's say there is a limitation for free tier. Let's say 5 GB. So this 5 GB free forever. You no need to pay. If you want to store more than 5 GB, that is unlimited data, you can go with the pay as you go basis pricing model. Pay as you go basis means my expectation is 1 TB data, but no need to pay immediately 1 TB data. How much storage you have today? Today I have 15 GB. Then you can pay only for 15 GB. No need to reserve 1 TB space. 1 TB space, it is highly scalable. Today you have 1 GB, you can pay only for 1 GB. Tomorrow you have 10 GB, you can pay for 10 GB. After a month you have 50 GB. Whenever you store 50 GB, then for that amount only you can pay. It will scale automatically. You can store any size of data. Your S3 storage scales automatically. You no need to reserve space at the beginning. You can store the data, it will scale automatically. It is highly durable, highly fault tolerant, highly available. 24 by 7, you can access data from anywhere. It supports different formats. It supports encryption, versioning, lifecycle policies, and it provides access controls. You can give read only, write only, delete permissions. You have multiple policies to access this S3 data. Based on the user level, you can restrict access control on S3 data. Okay? Yeah, yeah. Let's continue, team. Let's continue Amazon S3. Let's understand Why Amazon S3 or why AWS S3? What is the main features available in S3? Why people are choosing S3 for their storage? First important point is scalability. Scalability. Let's say this is my S3 service, S3 service in AWS. So I'm working for X client, X client. Let's say here X client having e-commerce app. That e-commerce related complete data they are storing it into S3 location. They created a bucket. They created a folder. In this folder, they are writing into sales data. Their complete sales data into this location in Parquet format. Let's say Parquet format. So daily they are storing that data into this location. Let's say today they have 1 GB and daily data growing, not like anything. After month, let's say it contain around 20 GB data, 20 GB data, and after 6 months it has around 1 TB data. Like this, it is growing. It is growing. Data is growing, not like anything for this X client. So this is not a fixed size. Based on your storage, based on your storage, this one scales automatically. It supports unlimited storage. Unlimited storage. It will scale automatically. Next point to thing. And it is highly durable and highly available. 99.9999% it is durable and highly available. And AWS S3, AWS S3 is not for particular region. It is a global. It is a global in AWS. AWS we have multiple regions, right? So AWS S3 is a common for all regions. It's a global. Next point. Data is stored across multiple availability zones. Across multiple availability zones. Let's say mine is banking or my project is finance related. I need more availability. If assume if uh, my if I choose default one availability zones, assume if I choose only availability zone, what happen? If that entire availability zone is not available, we may face. So we can span our data multiple availability zones. You can configure multi-availability zones. So your data replicates into multiple availability zones. Next one, security and access control team. Security and access control. So in AWS, for X client project, we have 10 developers, 10 developers and two testers, two testers, one administrator. one administrator. So based on these developers, testers, and administrators, based on their role, we want to give access on X client S3 buckets. So here security and access purpose, AWS, I am having different policies for S3. You can assign corresponding policies to developers, testers, and administrators. Based on that, they can access. Let's say developers, we want to give read and write permission. Testers, we want to give only read permission. Administrators, we want to give read, write, delete permission. So depends upon their role, we can customize policies. We can assign corresponding policies to particular users so that we can provide security and access controls on the data. Along with this one, we have a data encryption algorithms. So we can encrypt and store the data. For that, AWS S3 providing different encryption algorithms. Different encryption algorithms. And next important one is cost effective. Cost effective. Let's say today I stored 1 GB data. You can pay only for 1 GB data. My data after a month it grows to 20 GB. Then you can pay from that day onwards you can pay for 20 GB data. After 6 months my data is grown to 1 TB. After 6 months onwards you can start paying for 1 TB data storage cost. So it is pay as you go basis model. Second one, let's say uh, 10 years data, 10 years data. In that, I want only current 1 year data. 9 years data, I do not want more. I am not using frequently. 9 years data, I am using, but not frequently. These 9 years data, instead of paying standard cost, we can reduce cost using different storage classes. You can select a different storage class for these 9 years data so that you can reduce your cost of your S3 storage data. Yeah. Next important one, performance team. Performance and fast access. So here, if you are using regular and if you are using data continuously, then we have a storage class called standard storage class. So store your S3 data in standard storage class, then you can retrieve data in high speed. Let's say I'm using some data very rarely. Then you can go with glacier kind of storage. Read writes are little slower. If data is less requirement, move such kind of data to uh, different storage classes. For normal or regular purpose, you can select a standard storage class. It is super fast. You can read, write your data with high speed. Next one thing, next very, very important one. AWS, sorry, AWS S3, you can integrate with any other AWS services. Let's say Let's say uh, this is my AWS cloud, and this is one service S3, S3, and we have 200 plus services, 200 plus services. Any service can can be used to integrate with S3 for storing the data, retrieving the data. You can use any service, but only one thing, if you want to access here, you need IAM role. IAM role. So you need to attach IAM role to that service so that a service can, a AWS service can access AWS S3. Any AWS service can access S3 by having a IAM role. For outside, we have Boto3 API for different programming languages, different programming languages. Using this Boto3 API, they can also connect to AWS S3. So integration with AWS services. Any AWS service can communicate with S3 for storing the data, retrieving the data, deleting the data, updating the data for any purpose. But only one thing, middle, you need a IAM role. Okay, clear, right? Why AWS S3? Yeah. Let's continue Amazon S3 team. In this, let's start understanding advantages of Amazon S3. So scalability, it will scale automatically. You no need to select a fixed size. I want 1 TB storage. I want 1 petabyte of storage. Like that, you cannot pay money to like other storages. You no need to select a fixed size. Based on your storage, you can pay. It will scale automatically and it will support unlimited storage. And it is 99.999% durable and highly available. Highly available and cost effective. Today, if you are storing 1 GB, you can pay. Let's say other storages, we first buy the storage. Let's say we purchased 1 TB, but until a month, we have only 1 GB data, 1 GB data, but we purchased 1 TB data. But here, S3 location, if you store 1 GB, you can pay for only 1 GB. Until 1 month, we are using only 1 GB. So until that entire month, you can pay only for 1 GB storage. And it supports different encryption algorithms to protect your data. And also, we use IAM, IAM service to provide security to access your data. And it is global access. Global access. So AWS S3 team, let's say this is S3, S3, and in this we have different regions, different regions. Let's say this is my Mumbai region, Mumbai region. In this Mumbai region, I am creating S3 bucket, S3 bucket. Let's say bucket name is B1, B1. So let's say they have assume 50 regions. In entire 50 regions, This bucket B1 is a common name. Let's say user1 is created this bucket 1. Let's say another region, let's say Canada region, and user 1000 wants to create a bucket. He is trying to create a bucket B1. It is not possible because it is global. Bucket names are global plus from anywhere in the world, you can access this S3 bucket. S3, S3 data, global access. And next one, you can use any AWS service. Any AWS service, you can access this S3. Middle, you need IAM role. So we create a IAM role. Let's say glue. We are writing job 1. We attach this role to job 1. Then this job 1 having a capability to access S3. For other programmatic approach, they given Boto3 API. Using this Boto3 API, they can communicate with S3. And next advantage is data versioning. You may heard this versioning concept in version control systems like GitHub. So there, whatever advantages we are getting in that version control systems, similar advantages we can get from S3. Let's say same location, same file name. If you are storing, there may be a chance of loss of data. New file overrides old data. If new file is a smaller size, old file is bigger size, we may lose. So to resolve such kind of issues, we can maintain different versions so that we can retrieve whatever the version we want. We can create a different life cycle management so that we can move your data between different storage classes for optimization purpose. Let's say, let's say our X client started 2020, 2013. Assume this year is 2020. Assume current year is 2020. So in this S3 location, S3 location, we created a bucket. In that bucket, we created year equal to 2020 folder. Then we stored 2020 entire related data and we selected standard class. Assume 2020 is completed. Now 2021. We created another folder 2021. Then we are storing current year data. Like this 21 is completed, 22 is 23, 24, now 25. So we are using only current year data. Previous years we are not using regularly. You can maintain life cycle based on that. You want only current year data in standard storage classes. Remaining years data, you want to move it to different storage classes for reducing the cost. So you can maintain life cycle management. It will automatically automate data movements between different storage classes to optimize your data. Next important advantage is cross-region supporting data replication. Data replication. Let's say You are in Mumbai region. In this location, you selected S3. You selected S3. You are storing data here. You want to protect, you want to replicate this data into another region, let's say Canada region. You can select, you can select cross region replication, CRR, cross region replication. Same data is going to replicate into another location, another location. Mine is banking company, mine is financial sector. I need more. I do not have a cost issue. I need my data available 24 by 7 up and run. I do not have a cost issue. Even though AWS saying 99%, 99.99% durable and highly available, but still my business is finance. Even fraction of seconds also problem in particular region, I may lose a lot of uh, I may lose lot of money because mine is finance sector, mine is banking sector. I do not want to face such kind of issues. Then you can replicate your data into multiple regions. Amount is not issue. I need a data. Data should be available 24 by 7. Example, let's take Amazon e-commerce application. Let's say storage is not available in 1 minute. How much of data they may lose? How many orders they may lose? So they do not have a cost issue. They want data should be available at any cost. So they can maintain these kind of replications. So S3 provides cross-region replication. Same data you can replicate into different regions too. Okay. And it provides, it is a serverless architecture. You no need a infrastructure. Say, I want to these many missions to store. No, it is a serverless architecture. So no need of infrastructure manually set up or manually select. Backend, they may use different storage techniques to store the data. Mostly, we can also use this S3 for storage purpose also, backup and restore purpose. And on this data, we can apply different analytics using different technologies like Athena, Redshift, Glue, EMR. Performance wise, it is high speed data transfer with multi-part upload for large files. And let me add one point here is first important file system changed entire world architecture is HDFS file system. HDFS file system. HDFS file system stands for Hadoop, Hadoop Distributed File System. Hadoop Distributed File System. File System. Hadoop Distributed File System. This is most popular file system for supporting unlimited storages and supporting distributed. It will distribute data into multiple machines and it supports parallel processing. So first popular file system is this one. And almost all cloud file systems, AWS S3, AWS S3, Azure Blob, Azure Blob, Azure blob, blob storage, Google Cloud Storage, following similar style of storing data, similar style of storing data. So that's why nowadays people stopped storing data into HDFS. People are going for cloud storages. You no need to set up. If you want to do this one, you need to create a cluster. You need to create a fixed cluster. Let's say I want to 500 missions. I want to 1000 missions. Like that, you need to set up and you need to do lot of administration tasks. So here, coming to cloud file system, zero maintenance. It is serverless. Serverless. It replicates the data internally. It provides data parallel processing support. Similar kind, but a lot of advantages compared to HDFS file system. There you need to set up, configure, manage, admin, lot of activities you have to do. So all cloud file systems following similar style with serverless architecture. Okay. Yeah. Yeah. Let's start it. In this session, we are going to discuss what are prerequisites for AWS S3. As part of Amazon S3, let's start understanding what are prerequisites for S3. First point. So AWS S3 is a storage service. AWS S3 is a storage service. S3 is what? Storage service. It is a storage service. Let's say user wants to access this S3. User wants to access S3. Then first user must be having a permission. User must be having a permission. Let's say here we have user. User must having a policy. Let's say S3 policy. User must having a policy. Then only user can access S3. Second one. Second one. Root user. Root user can access any of this service. First point, root user can access any service in AWS cloud, but normal users are IAM users. So IAM users must having policy to access S3. Second one, other services like Glue, and Athena, etc., etc., Athena, etc. Okay, these these are other services in AWS cloud. If these services wants to access this one, here we need to create a role. We need to create a role. Then we are going to attach that role to corresponding service. Then only a service can access S3. A service can access S3. Next one. If I am using application like Java application, Python application, etc., you need access key, you need access key, and you need secret key. So as a user, let's say I'm writing this application in user one. So as a user, you need to create keys. You need to add those access keys, secret keys in application. It means if you observe, I am playing important role in accessing S3. So first you need a account, you need account, and then basic knowledge of AWS plus very importantly IAM is required to IAM knowledge is required to interact with S3 if you want to put restrictions to access S3. Maybe user, maybe application, maybe other service. And additionally, AWS CLI is optional. AWS CLI is optional. Instead of using AWS Management Console web user interface, we can interact with S3 using AWS CLI. AWS CLI. Okay. Next one. Moto 3. I said this is if you are writing application, through application, if you want to connect, you need Moto 3 knowledge. So main required is AWS account, basic knowledge of AWS, then IAM knowledge. These three are minimum requirement to interact with AWS S3. Okay. Yeah. Now let's continue Amazon S3. In this, we are going to see creating bucket and creating folder inside a bucket and uploading file inside a bucket inside a folder, then deleting a file, deleting a folder, and deleting a bucket. These operations we are going to see. Yeah, first point, bucket team. Bucket. Let's say this is my AWS cloud, and I logged in into AWS account. I selected region Mumbai. Mumbai region I selected. In this Mumbai region, I'm selecting service called S3. I'm selecting service called S3. S3 is a storage service. S3 is what? Storage service. It is a storage service. In this, I want to load the data. In storage service, I want to load the data. So to load the data into S3, we need to create a bucket. So first important point about S3 is we need to create a bucket. Let's say I am creating bucket 1. Let's say B1. This name is a unique name. This name is a unique name. This should not be exist in any of the region in AWS cloud. Let's say uh, 30 regions are there. 30 regions. Canada, USA, UK, etc. Total 30 regions are there. Assume in 30 regions, this bucket name should not be exist. So bucket name is a global name. It should not exist in any other regions. So bucket name, whatever the bucket name you are going to create, that is a global. So name is global. So that name should not be exist. Then only it will create. So once we create a bucket, inside a bucket, you can load the file, you can create folder. Okay. So in this, first let's start understanding bucket creation. Bucket creation. Okay. So go to AWS Cloud and go to AWS S3. And in this AWS S3, here you can see first we can see Amazon S3 like this. If you do not have any buckets, if you do not have any buckets, if you search S3 and if you click on S3, then it will open in this way. I already created some buckets. That's why it is opened buckets location. So here click on create a bucket. And here you can see bucket name. Bucket name must be 3 to 62 characters and it is unique and within the global namespace. I am creating bucket saying uh, S3 hyphen demo. Let's say Akkem hyphen Akkem Sreenivasa hyphen S3 hyphen demo. Then here you want to give this bucket access throughout the public? If yes, uncheck this option. See, once we uncheck, here it is going to open a option called acknowledge. Uncheck this one. It is asking, I acknowledge current settings. Yes. Then here, all these are options are optional. Later, we are going to discuss about versioning. Later, we are going to discuss about encryption. Okay. At this point of time, you can leave default settings. Then click on create a bucket. So bucket is created. Bucket name is Akkem Sreenivasa S3 demo. Clear writing how to create a bucket. Now for you, for me, for you, for me, for other persons, whoever working in AWS world, for all them, this name is unique. You cannot take same name, Akkem Sreenivasa S3 demo in your account also. It should be unique name across AWS cloud. Yeah, yeah. You can click on this bucket. So every bucket having unique name. You can click on properties. You can see properties of AWS bucket. Okay. Here, this is Amazon resource name. This is unique name. This is unique name. Later, we are going to use this ARN for accessing the bucket. At this point of time, just concentrate on bucket. In this bucket, we do not have any folder and any file. Okay. So next one, in bucket, I want to organize data like this. All input files, I want to create a folder, then I want to place. All processed data, I want to create another folder. I want to store in that data. Okay. Let's say here we have a option saying create folder. You can create a folder like raw data. Create a folder and click on create another folder, processed. Processed. Then I am creating folder. You can upload file directly into bucket. You can click on upload. You can click on add file. You can select a file from your system datasets, and here I have a S3 location. Here I am selecting EMP file. Then click on upload. Or, or you can go to particular folder. Then you can click on upload. You can add a file. You can select one or more files. Then click on open. At a time, you can upload multiple files also inside a bucket or inside a folder. Inside a bucket or inside a folder, we can upload one file or multiple files. Okay. Next one tip. Other approach. Let's say under process, I want to upload a file. We seen upload add file, or you can go to particular location. You can go to particular location. You can select a file. You can just drag and drop. You can just drag and drop. Then click on upload. You can click on upload, or you can just drag and drop. Next one tip. I want to upload a folder directly. Click on upload, then click on add folder, select a folder. It will select entire folder. You can upload entire folder. Entire folder. You can upload entire folder. You can drag folder. Let's say you can drag a folder. You can drop a folder also. Like file, you can drag folder. You can directly upload folder to bucket or another folder. Okay. So now I am showing how to delete a file. Select a file. Here you can click on delete and you can type permanently delete. You can type permanently delete. Then click on delete object. Click on close. I want to delete a folder. Then select a folder, click on delete, then type permanently delete, then click on delete object. I want to delete a bucket. Go to buckets, select a bucket, then click on delete. When I try to delete, it will not delete because my bucket contain folders, my bucket contain files. Let's try to delete. Here it is giving error saying bucket is not empty. Okay, you can select a bucket. You can select a bucket. Go to bucket. You can select a bucket. You can click on empty. You can click on empty. Then type permanently delete. Then click on empty. It will delete all files, folders under bucket. Means it will clear everything. After that, you can select a bucket, then you can click on delete. Now it is not showing that error message. You can just copy your bucket name, then place this bucket name here, then click on delete bucket. In this way, we can delete bucket. Okay, let's set in. Let's set in. I created a bucket to saying AWS hyphen S3 S3 hyphen demo. S3 hyphen demo. I created bucket for assume for my batch 100. Batch 100. Batch 100. I have created uh, folders in AWS hyphen S3 hyphen demo. So batch is completed. Then I am my free trial also completed. I created another account X. Then in this account, again I am trying to use AWS hyphen S3 hyphen demo. Then it will not work because bucket name already existed. You will get error saying bucket name already existed. So bucket name should be unique. So that's why what I'm going to do once my practical training explanation is completed, I always remove bucket. Otherwise, I cannot reuse that bucket name. I cannot reuse that bucket name in another account. Clear, right? Why we are deleting bucket? If if bucket is not required, then delete bucket. Later, we can reuse same name in another account also. Yeah, clear, right? Tim? How to create a bucket, how to create a folder, how to upload a file, how to upload a folder, how to delete a file, how to delete a folder, and how to delete a bucket. Yeah, let's continue Amazon S3 team. As part of Amazon S3, now let's continue AWS S3 storage classes. Very, very important in AWS S3 team, storage classes. When you are putting experience into AWS, maybe developer, maybe AWS admin, maybe AWS data engineer. If you are putting S3 as your experience, you will get one question on AWS S3 storage classes. So first question, do you have any idea about storage classes? And what is the storage default storage class? These are different storage classes. These are different storage classes. Okay. And in this default storage classes, AWS S3 standard storage class. When we go for the storage classes, your requirement is frequently writing the data, frequently reading the data from your Snowflake. Sorry, your S3. In your S3, you are writing the data, you are reading the data. It is highly recommended to use S3 standard storage class. Second point, you no need to specify explicitly S3 standard class. Whenever you are creating bucket, whenever you are uploading a file, or whenever you are uploading a folder, then default storage class is S3 standard. For this S3 standard, compared to other storage classes, compared to all other storage classes, cost is high, 99.999% available and durable. It never failed. It never failed. Yeah. Next point to take. My requirement is my requirement is I have data like 2020, 2020 data, and this is separate folder, and 21 data, this is separate folder, 22 data, separate folder, 23 data, separate folder, 24 data, separate folder, 25 data, separate folder, separate folder, and 26 is coming, 26 also I am creating separate folder 2026. So my current business required only current year data. Then these data we do not require every time. We may require when it require is when new festival is coming. I'm taking all 6 years data, I'm doing analysis. But everyday operations, end of the day, I'm doing operations, ETL operations, or weekly, I'm doing weekend, I'm doing weekly operations, monthly, I'm doing monthly operations, quarterly, I'm doing quarterly operations, half yearly, I'm doing half year operations, and year end, I'm doing year end operations. For that, I need only current year data. Previous year data is required, not every time. Some important occasions, I'm going to use that one. Otherwise, I do not want the data every time. Occasionally, I want to use the data. So for all these data, I do not want to use standard storage class because compared to other storages, it is high. Then to reduce cost, we have different other storage classes like S3 intelligent tiering, S3 standard IA infrequent access, S3 one zone infrequent access, S3 glacier, S3 glacier deep archive for reducing cost. See, intelligent tier is medium. Uh, Infrequent access is lower. One zone infrequent access is lower. S3 glacier is very low. S3 glacier with deep archive is cheapest. But data is available 99.99%. It may be any storage classes, data is available, but retrieval speed is differ. Compared to standard is read write is very faster, little slow, slow, very slow, slow, very slow, very, very slow. Like this, depends upon the storage classes. But price is low, very low. So most of the time, for regular uses, we go with S3 standard. For occasional uses, we go with S3 Glacier or S3 Glacier with deep archive. To reduce cost. Clear, right? What is the purpose of storage classes? Yeah, let's see it. Let's implement, let's implement practically. Yes, correct. Yeah. So let's see. Uh, let's see. Uh, in this, let's see practically. First, create a S3 bucket. If not created, then upload sample file in S3 bucket. If not uploaded, then check whether it is assigned standard S3 standard class or not. Okay, go to S3, then create a bucket. I am creating bucket Akkem Sreenivas hyphen S3 hyphen demo. Okay, let's uncheck this option. Select I acknowledge, then create a bucket, then go to this bucket, then upload a file, go to datasets, go to S3, upload this file, EMP file, then click on upload. Click on upload. Then check whether storage class is assigned to this emp.csv or not. So go to storage class bucket. So first select here. See, select a file. Go to properties. Here you can see object, and first go to bucket, select a bucket, click on bucket. Here you can see properties. So in this properties you can see versioning, bucket ABC, then default encryption and intelligent trialing and server access logging, event notification, event bridge, some other properties. Okay. So once you select adding upload files, here you can check uh, select a file, then select a storage class. You can select a file, go to object, here select a file. You can see here actions, you can see edit storage class, edit storage class. Here by default, what is the storage class for my file? My file is standard storage class. Standard storage class. Then whatever storage class you want, you can select here. You can select storage class. Let's say I want to select Glacier Deep Archive. Then click on select class, save changes. That's it. Click on close. You can select a file. Let's say create one folder, folder name raw. Then click on create a folder, select a folder. Okay. Click on actions. You can see edit to storage class. Let's say 2020. I want to make it as deep archive. 2021. I want to make it as deep archive. 2022. I want to make it as deep archive. 2023, 2024, 2025. But 2026, I want to make it as standard. By default, if you create, it is standard. Clear, writing? How to specify a storage class to particular folder or particular file? Yeah. Let's starting. As part of Amazon S3, let's start understanding. Next important concept is AWS S3 versioning. Let's understand the purpose of versioning team. Let's say this is my AWS S3 service, AWS S3 service. In this AWS S3, we have bucket. In bucket, let's say we created folder. In folder, let's say we loaded a file, let's say sales file, sales.csv, sales.csv. Let's say today we loaded this file. Today we loaded this file, and tomorrow, let's say we are loading. uh, Tomorrow we are loading same file. Let's say today we have 10 records, and tomorrow, let's say we are loading same file again in same location. Let's say tomorrow, let's say 1000 records. Day after tomorrow, again we are loading same file, then 10,000 records. That's a 10,000 records. And some other guy also loading a file in this location. Let's say random guy loaded file into same location. Then that contain only one record. What happened? If you load new file in existed bucket, it will overwrite old file data with new file data. So finally, we are having a file with one record. Data analytics people using this file, they are generating reports based on this file. But new file contain only one record, they report giving wrong outputs. Management seeing wrong output because we have only one record. They are not getting latest output into their reports. They are complaining. Then uh, let's say we removed file from our local file system permanently. After uploading, into S3, we removed file permanently from our local system, our source location, because AWS S3 is 100% durable, reliable. Your data is 99.99% available. So you are trusting S3, then you removed your local file, but someone is loaded, uh, random guy loaded, you lose all the data. How we can resolve this issue? Instead of facing this kind of issues, if you manage versioning, you can enable versioning at the time of bucket creation or later also. After creation of bucket also, we can enable versioning. If we enable version, if you upload same file, then it says V1, V2, V3, and V4. Then our data analytics team raised a request. They want a previous version. Then we can go AWS S3 console. Then we can re we can find previous version. We can download and we can re-upload. Now you will get this data. We never lose. It is like version control systems. How GitHub maintains different versions, right? Similar way, in AWS S3 also having versioning. If you upload the same file in same file in same location, it will create a different version. And always you get latest version data. If you want a previous version, you can go to version location, then you can find previous version, whatever the version you want. Let's say customer wants to first version, then you can go to first version, you can download, you can re-upload. Whatever the version you want, you can select it, you can download it, you can re-upload it. That is the main advantage of AWS S3 versioning team. Let's see practically. I already opened this AWS S3 console. This is my bucket. Let's say here, let me remove this bucket, empty bucket, empty bucket. Then select this bucket, delete the bucket, select the bucket and delete the bucket. Let's say I am creating a bucket. Here I am giving bucket name. Okay. Let's edit. Here, let's scroll down. I am enabling public access. Then I'm selecting I acknowledge. Along with this one, see bucket versioning. Bucket versioning. Here, by default, it is disabled. You can select this one. Okay. Let's click on enable bucket versioning. Then click on create a bucket. Now let's go to our data location. Okay, go to datasets. Here, go to S3. Let's say versioning. Versioning. Let's take a file. Let's take a file. In this file, I have 11 records, one header. Let's upload this file into S3 bucket. Let's upload this file. Let's upload this file name. Click on upload. Later, what I'm doing, I am removing some records. Then upload this file. Upload this file once again. Click on close. Now let's upload this file once again. Click on upload. Click on close. Then again increase, save, then add some more, save this one. Let's upload file into this location. Then click on upload. Click on upload. Once again, let's say let's reduce data, save this one. Let's upload. Let's say we uploaded same file but less records. Now finally, how many records file we have? Only one record file. Yes or no? Let's select this one. Let's click on download. Then open this file. Finally, we are seeing only one record. Yes or no? Only one record we are seeing. But my client is asking previous complete data file. Then how we can find versioning? How we can find versioning? So we created a bucket and we selected versioning. Then we uploaded file. Okay. We uploaded new versions files. Then view all versions. So first to select a bucket. Click on objects. Show versions. So these are first select a bucket. Click on objects. Then show versions. How to select a version? Let's go here. See, go to actions. See here, we see, yeah, click on this object. Let's see here. We can see properties here, bucket properties, storage class, and tags, metadata, metadata. Click on versions. See, complete versions. Select the version you want. Then click on download. Go to location. Click on this one. You got all records, right? Then re-upload it. Re-upload it. Re-upload this one into S3. Yes, correct. You don't need to do anything. Just enable version. That's it. Yeah. Let's continue Amazon S3 team. In this session, we are going to discuss encryption and security in AWS S3 with examples team. With examples. So first, let's open Amazon S3, and here this is our S3 bucket. S3 bucket. So here we loaded a file. We loaded a file. Now let's understand. Uh, now let's understand encryption and security in AWS S3 team. So first point team. This is my AWS cloud. AWS cloud. Okay. AWS cloud. In this AWS cloud, we are using storage service S3. We are using storage service called S3 for our storing history of data. For storing history of data. Okay. S3 and for storing history of data, storage layer. Here we create a bucket, and inside bucket we create folder. Inside folder we will write our data. Let's say files. We load our files. First, let's understand security. Let's understand security. If you want to access this data as a user, user 1 to user n. If you want to access this data, user 1 to user n, then first you need what? IAM policy. Yes or no? You need IAM policy. Without S3 policy assigned to you, without policy assigned to your user, you cannot access this S3. Second one, I am writing Glue application, Glue app. Okay, I am writing AWS Glue app. I am writing Athena queries. Athena queries to read this S3 data without role assigned to your Glue application and Athena. They cannot access S3 data. Yes or no? So first level security we are achieving using IAM. If it is a user, we will create a policy. We assign policy to user. If it is other services like Glue, Athena, we will create a role. We assign role to application or Athena service so that that services can access S3. Now encryption. Now let's understand encryption. Encryption. You are uploading a file. You are uploading a file. Uploading a file into S3. Let's say user 1 having IAM policy, then he is uploading file into S3 bucket. He is uploading file into S3 bucket. So here we have server side encryption. Server side encryption means S3 side we have encryptions. Server side encryption with S3 managed keys. Server side encryption with AWS key managed services, or dual layer server side encryption with AWS key management services like this dual layer key service. So these are encryption algorithms available at S3 side. S3 side. You can choose any of these algorithms to provide encryption to your files. Second one, client side application. Client side application. Sorry, client side encryption. Let's say you are using Python, you are using Java, you are using Spark for uploading the data, uploading file into S3, uploading file into S3. Yes, here you can write client-side encryption algorithm to encrypt your data into S3 file system. Clear, right? If it is your application is writing or uploading file into S3 location, then you can write client-side encryption logic to encrypt data and write into S3 location. By default, AWS S3 having server-side encryption. We have different encryption algorithms. One default encryption key presented in S3. You can use server-side encryption with Amazon S3 managed keys. That is the default one. Second one, you can put a keys in AWS key management service. Then you can use that key to encrypt the data. Third one, dual layer server-side encryption with AWS key management service keys. These are three algorithms. By default is server-side encryption with Amazon S3 managed keys. Let's see it in practically. Server-side encryption. So server-side encryption. Let me create a S3 bucket. Let me create a S3 bucket. So I am creating bucket. So I'm giving bucket name Akkem hyphen uh, uh, Sreenivasa hyphen AWS hyphen S3 hyphen demo 2. Okay, this is my bucket name. And see here, I'm making it as public. I'm selecting I acknowledge. Versioning we discussed already. See, by default, by default, encryption algorithm is selected. You no need to do. You just create a bucket. Your data is encrypted based on Amazon S3 managed keys. This is the default. This is the default. So by default, uh, this algorithm is enabled. If you want other server side encryption, then there is a service called KMS, key managed service. You can put encrypted keys here, encrypted keys here. Then you can select this one. Then you can provide a path of this KMS location. Then based on that keys, your data going to encrypt. Okay. So by default, bucket is encrypted. Bucket data is encrypted based on server-side encryption with Amazon S3 managed keys. Click on create. That's it. Then if you upload the data into this bucket, if you upload the data into this bucket, then data is encrypted based on default AWS S3 server-side managed S3 keys. Clear, right? Additionally, if you want to client side, then whatever the technology application you are writing, there you can write client side encryption. By default, server side encryption is enabled for your bucket level. Yeah. Now let's see, as a part of Amazon S3, now let's see AWS S3 integration with the Python team. So here we are going to use Boto3 API for connecting S3 location. Let's say here what I'm doing, let me explain the uh, architecture for this example. Let's say this is my S3 under AWS. We have S3 service, S3 service. Okay. And here we are going to create a bucket. In this bucket, we are going to create a folder using my developer machine. Let's say here we are going to use our developer machine, let's say Windows. In this Windows, we are going to install Python. We are going to install Python and we are going to install Boto3, and we are going to install IDE like VS Code. Then we will write Python program. We will write Python program. Let's say uh, program 1.py. Then using Boto3, we are going to create a connection to S3. Then we are going to load our local file. local file, file 1, file, file 1, using our program 1 to in this location. Okay, clear, right? Let me explain step by step for implementing this one. First, you need a access key, secret key to achieve this one. So you need to create a user. If user is already existed, then create access key, secret key. Then get that access key, secret key, and then install VS Code, Python, Boto 3. In my mission, I already having Python. Let me open command prompt. Let me show Python space hyphen capital V. Next one. In my mission, I already have VS Code. Let me open VS Code. So this is my VS Code. Okay. I'm I'm going to open this workspace folder. So I'm going to open workspace folder. Let's say go to folder, go to folder, go to folder, go to folder, then let me, it is connected with SSH. Let's disconnect this one. Yeah, I disconnected remote connection. Then I am opening local my Windows folder. Let me open a folder, go to C drive, and here I have workspace folder. In this, I am creating Python for, I already having Python for AWS. Let's open this folder. Here, I am going to create a file saying AWS S3 integration dot py. Okay. In this, I am writing this code. I am writing this code. I am writing this Python code. In this Python code, first Boto 3 should be installed. How we can install Boto 3 is open a new terminal. Then here use pip install Boto 3. Press enter. Then it is successfully installed. My mission already installed. That's why requirements satisfied. In your case, you may not having. Then if you click pip install, it will install Boto 3 into your machine. Second one, I need access key, secret key, region. So go to your cloud. Here, see Asia Pacific, Mumbai, AP-South-1. Place this region name. Place this region name AP-South-1. Mumbai region is AP-South-1. Then I need access key, secret key. Go to AWS, open IAM service. go to IAM service. Then here, go to users. So this is my user already having. Click on this user. Then here I am going to create a access key. Click on access key. So remember, while creating access key, secret key, then provide where you are developing your integration application. Is it command line? No. Is it local code within the AWS? No. Uh, is it application going to run within AWS EC2 service? No. Is it a third party service? No. Is it developing, running outside of AWS cloud? Yes. Select this one. Then click on next. Give a description value. Just give any value. AWS S3 integration. Then click on create a key. So key is created. Copy access key. Enter this access key. Copy access key. Enter this access key. Then copy secret key. Then enter secret key. Okay. Then this is our S3 client. We are creating connection between our Python application to S3 using these steps. S3 equal to boto3 dot client function. Here we are passing S3 access key, secret key, region name. Then it will create a connection between your S3 with Python application. Once it is created, what I am doing? I am printing all bucket names. Bucket names. Then uh, provide bucket name where you want to create a file. Go to S3. Go to S3. Which bucket you want to provide? Let's say in this bucket. This is my bucket name. Bucket name should be exist before loading a file. So I am creating a bucket. In this bucket, I want to load my local file. My local file. Let's say my local file name. My local file name is let's say here under C drive, under datasets, I have S3. Let's say here I have emp.txt. Let's say I am passing this path. I am passing this path. Under this location, we have emp.txt. So you can use two backward slashes or one forward slash. This forward slash approach is Linux style of path. Then we are writing using put. We are writing using put and we are writing into location. See here, first we are specifying bucket name, our file location name. Then we are just printing bucket name. Then finally S3 dot get object, bucket name and object name. So this is for reading bucket data, because here we are reading object, not putting object. So this code is going to read the object. Let's say here, go to buckets, and in this bucket we have emp csv, right? Let's take this bucket name, demo. Let's say this is our bucket name. Let's change here logic of uh, bucket name and object key is emp.csv. So we are reading this data from our Python. Let me go to here. Let's run this program, Python space AWS integration.py. See, it is listing all bucket names and we specified file name. It is reading that file. Okay. So clear item, how to integrate Python with S3 from VS Code from your developer machine. Let's say Windows. Yeah, let's start it. In this session, we are going to start master AWS Glue. So as part of master AWS Glue, let's start understanding uh, what is AWS Glue. What is AWS Glue? AWS Glue is a fully managed ETL service. So first, let's understand what is ETL. ETL stands for extract, transform, and load the data. AWS Glue can be used to connect different sources. Let's say S3. S3. Let's say extracting data from S3, then applying transformation. Let's say this is my sales data. Sales data is presented in my S3 location. Then I want to filter records. I want to filter records based on city. I want to filter the records based on city. Then I can write a transformation, filter transformation. From extracted data, we can apply transformation. This transformed data we can collect and we can load into either again into S3 or data warehouses like Redshift, Redshift or data warehouses like Snowflake, etc. So whatever target, whatever input, whatever target, whatever target. So extract the data from different sources, apply the transformations, transform data you can load into any target. So this kind of implementation we can achieve using AWS Cloud. AWS Cloud, AWS Glue. AWS Glue is a cloud-based. It means you no need to install and configure. Same thing we can achieve using PySpark, but PySpark we need to set up a cluster. We need to set up a cluster. AWS Glue is a serverless architecture. It is fully managed ETL tool for data processing and data analytics. It is serverless team. What is serverless? Assume, assume ETL process purpose. ETL process purpose. Let's say I used PySpark. I used PySpark for ETL processing purpose. Let's say I developed this PySpark application in my developer mission. I developed this application where we want to deploy. Let's say we are taking different EC2 missions and we are setuping and we are configuring. Assume we set up 200 missions, 200 missions PySpark cluster. So we take EC2 machines, we install required software, then we create a configuration for master workers like that. Yes or no? So here we have to do lot of manual activity for installation and configuration and management purpose. Coming to AWS Glue, it is pure serverless. Serverless. No need to manage infrastructure. No need to create infrastructure like this. No need. AWS Glue automatically provisions resources as needed. As needed. Let me explain. Let me explain. This is my source. Source. Let's say source is S3. In this S3, there is a bucket. In the bucket, we have sales file. Sales file. Let's say sales file. Sales file. This sales file contain data. Let's say this data is 1 GB data. 1 GB data. You are using AWS Glue. AWS Glue to process this data. AWS Glue to process this data. You developed ETL application. You developed ETL application for taking this data and writing the data output into, let's say, Redshift. Redshift. So through this ETL application, final you are running this one. So for this, where you are running inside AWS Glue environment. Let's say you submitted this application. For this application, only one mission is enough. No need of multiple missions. If it is PySpark cluster, whether we required or not, we set up a cluster with 200 missions. But 200 missions are not required to process 1 GB data. Yes or no? You need to set up. But here it is serverless architecture. No need to manage infrastructure. The resource it created, it contained Spark software, Glue software inside it. Dynamically, it creates a resource and deploys your application and runs your application in this machine. Once the processing is completed, it will release these resources. Let's say I'm using, let's say sales data is 10 GB. To process 10 GB data, we need 4 missions. It will create 4 missions and runs this 1 GB data. Once execution is completed, it releases 4 missions. Let's say I am passing 1 TB data. Assume to process 1 TB data, we need 50 missions. 50 missions automatically creates, process your 1 TB data. Once execution is completed, it will release resources called serverless. Yeah, okay. So AWS Glue is a serverless. Dynamically, it will allocate resources. Once execution is completed, it releases resources. So it is cost effective. Cost effective. Let's say if you set up a physical cluster with 200 nodes, whether your input may be 1 GB or 10 GB, you have to manage this entire cluster. You have to purchase this hardware. You have to manage this entire cluster. Let's say your work is only less than a minute, and after minute, again you may get requirement after some time. Then you have to manage this cluster. But Glue creates a resource, execute your ETL job. Once execution is completed, it releases this resource. Let's say assume this resource used less than 1 minute and used 16 GB RAM, 16 GB RAM, then used 8 core processor. For 1 minute, they will calculate the pricing, they will charge for you. So it is cost effective. How, how many resources you used? How many resources used for your job? How many missions used for your job? How much time they ran? Based on that, they are going to charge. So we have to care while working with serverless architecture. And while setting this AWS Glue, we can provide I want a minimum of 2 missions, maximum of 200 missions. Within that range, it will create resources based on your input data. Okay, let's understand key features of AWS Glue. First important key feature is AWS Glue Data Catalog. AWS Glue Data Catalog. This is AWS Glue Data Catalog. AWS Glue Data Catalog. In this AWS Glue Data Catalog, we will store meta information of your input data. Metadata of your input data. Let's say your input is S3. Your input is S3. And S3, we have files. We have files. Each file information we can persist as a meta information like file name, file location, and file contained how many columns and what is the column data type. That meta information we can persist into AWS Glue Data Catalog. What is the advantage of persisting this metadata information into Glue Data Catalog? Initially, it is developed for Glue applications. Let's say I am writing ETL application, ETL application. Okay, I am writing ETL application using Glue technology. Glue technology. I am reading S3 file. Instead of writing that metadata reading logic from this file, I can get this metadata from this Glue Data Catalog. Then I can continue reading and processing of this file. Instead of defining schema logic inside my ETL job, I can get that meta information from Glue Data Catalog. Then I can proceed reading and processing logic. I focus on this one instead of spending defining schema logic inside my ETL job. Initially, this was developed for Glue job implementation. Because of this Glue advantage, multiple services like Athena also wants to read this file. So they can also access this metadata, then read that data based on this metadata information. Like this, multiple services using this metadata information. That's why they made it as a central repo to multiple services. They are treating, not maintaining, they are treating this AWS Glue Data Catalog as a central repository for multiple services. If they want to read this file, instead of developing schema definition in their technology, they are connecting to getting that meta information. and processing. So one important key feature is AWS Glue data catalog. Next one. Next one. Automatic schema discovery. Automatic schema discovery. This is my input file. S3. S3. Okay. Here we have a bucket. Here we have a file called sales. Sales. So sales file, initially we have 10 columns. 10 columns. Let's say today it has a 10 columns. We created the definition in our Glue data catalog. Okay. We are writing ETL application. We are processing this one. And new file they loaded, they added one more column or two more columns. Then here it will detect this definition. Let's say automatic schema discovery feature. Automatic schema discovery feature. We can enable this automatic schema discovery. If any change in our input data, we can update that schema information in our Glue data catalog so that our ETL job never fail. Our ETL job never fail. Our, let's say, Athena, we are writing analytic queries. These analytic queries never fail. Let's say based on the timestamp, today we have different timestamp, tomorrow different timestamp. If timestamp changed, it go input location, checks is there any schema change. If any schema change, it update that schema information into metastore. Next one thing, it has a ETL engine. ETL engine. What is the purpose of this ETL engine? Let's say, let's say, let's understand key important feature of ETL engine. In AWS Glue, AWS Glue, it is providing drag and drop, drag and drop feature, drag and drop feature. So source, source and transformation, transformation and target. Let's say source is S3 and S3 file location, S3 file location path and transformation, let's say filter and target, let's say redshift, redshift. You have a feature of drag and drop, then modify properties means S3 path location, filter condition and target properties. Just to change the properties, then ETL engine will taken care to convert this code either Python programming format or Scala format. Scala format default is a Python format called, it will generate a PySpark code. It will generate a PySpark code. If you choose Scala language, it will generate a Spark and Scala. Spark and Scala. So you can choose a language of code generation of your AWS Glue ETL job. By default is Python. So it will generate code, PySpark code. Once a code is generated, you can do modification. You can edit the code if you not like it. If you add new code or if you want to add some additional feature to generated code, you can do. Or you can AWS Glue provides one drag and drag and drop called graphical approach, drag and drop called graphical approach. Second one, if you want to write direct code, then it provides programmatic approach. You can write PySpark with Glue API. You can write code manually. This generated code also we can edit if you not like it. If you satisfy, you can use it. If you not like it, you can edit. If you want to add more features, you can edit and add new features to generated code. And next important feature is job scheduling. You no need to depend on different scheduling tools like step functions, like Airflow. You no need to depend upon uh, different tools for scheduling Glue jobs. Glue itself contain a job scheduling feature. You can define your scheduling using Glue, but it works only for Glue jobs. That said, yes, that's what I'm saying. This scheduling works only for Glue jobs. Let's say I want to schedule uh, Athena jobs. I want to schedule uh, Lambda jobs. I want to schedule Kinesis jobs. Then it will not work. It will work only for Glue jobs. If you want other AWS services jobs also, I want to orchestrate or define data pipeline. Then AWS having a feature separate service called AWS step functions. For any AWS service, you can define data pipeline or orchestration using AWS step functions. Along with AWS, I want to define not only AWS, I want to define anything. Then we have multiple tools. There is one powerful software is Apache Airflow. So if you are working only Glue jobs, you no need other scheduling tool. You can use this job scheduling feature. Along with Glue, you are using multiple other services. Go with step functions. Your project contain only AWS services. Then go preferred one is AWS step functions. Along with AWS services, you may have other technologies outside of AWS. Then recommended one is multiple other data orchestration tools like Apache Airflow. So AWS Glue itself contain a scheduling feature. And next one thing, data ingestion. You can use AWS Glue. You can connect with the different sources. You can ingest data into these services. You can ingest data. I do not want any transformation. Just I want to move data from S3 to Redshift to S3. No need of writing complex logic. Uh, or no need to manually write. You can just to drag source, you can just to try target, and transformation is just data movement logic. That's it. It will generate a ETL code for your data ingestion. Then you can use that code, you can run. You can move from one source to other source. Next one, scalability team. So we understand it is a serverless. It is a serverless. Yes, scalability team. Here, let me open AWS Glue service team. Let me open AWS Glue service. Here, we can create ETL job. Let's say ETL job. Here, there is a job details. Here, you can see here worker type, worker type. Here, we can provide how many workers you want. You can provide how many workers you want. Based on this, it will scale your cluster. Let's say minimum I want to 2 missions, maximum 100 missions. Your data is 1 GB. Then it creates only 2 missions. Your data is 10 GB. It will create, based on data size, it will create more missions. Scales automatically. No need of a physical cluster. It will create resources based on your data load, and once the processing is completed, it will release resources called dynamically scaling resources based on the workload. And security and monitoring team. Security and monitoring. By default, by default, we get security from IAM. See, in Java, we have IAM role. Let's say I am developing Bluejar, this Bluejar. Let's say job one, sorry, job one dot py. Here I'm writing blue ETL job. I'm writing blue ETL job. This job want to access S3. S3. This glue job wants to write output into Redshift, Redshift or other service. Then we create a role. We create a role. For this role, we give read of S3, write of Redshift. Then we assign that role here. We assign that role here so that a glue can communicate with these services. By default, a service cannot have permission to access other service. A service cannot have access to other service. So first level security we can achieve using IAM role. Next one. Let's let's say we are 20 members. For all 20 members, I do not give AWS Glue access. Then we can achieve by using AWS IAM. while assigning permission to user, I cannot give AWS Glue access for some users so that they cannot access AWS Glue. Such kind of securities we can get using AWS IAM. Next one, Tim. We return ETL job. I want to know what is happen once processing. It may fail, it may success. I can configure CloudWatch to my ETL job so that I can go and watch AWS CloudWatch about this ETL job. Okay, so we can have a security and monitoring in this AWS Glue. You no need a separate configuration. By default, a CloudWatch attached to your ETL job, you can go, you can verify logs. Okay, yeah. Any question up to now? Yeah. Now let's understand. We understand what is AWS Glue. We understand key features of AWS Glue. Now let's understand why use AWS Glue. First one, if you use PySpark, you need to do lot of manual coding and you need to deploy debugging purpose, lot of activities you have to do. So it reduces ETL development time by providing drag and drop feature and it will generate a code. Later you can edit if not satisfy some parts. So it will reduce a lot of manual efforts. Next one, simplifies data management. So we can use AWS Glue to unify data from multiple sources into a single searchable catalog. I have different sources, source 1, source 2, source 3, source 4. For all these sources, you can create a metadata in a single location. Then from my application, it is easy to search, right? Instead of going and connecting different sources, reading and writing this logic, this is very easy. We can easily get all that sources information in single meta location, right? And next one, Glue supports multiple file formats. It supports CSV, JSON, Parquet, ORC, Avro. It supports all file formats. And I said ETL engine. You just configured source, filter, and target. And it will generate a PySpark code, I said. It will generate optimized code. Okay. And we can integrate with different AWS services. AWS Glue can be used to integrate with different AWS services, S3, Redshift, and many other services. You no need separate mechanism. You need only access permission. So using AWS IAM, we can give, we can create a role and we can attach role to our ETL job. Let's say I want access of S3. You can give read access. I want to write access of Redshift. You can give, you can attach policy to role. Then you attach that role to glue job so that a glue can communicate with different AWS services. Okay. Yeah. Let's start understanding use cases of AWS Glue. As part of master AWS Glue, Let's start understanding use cases of AWS Glue team. So AWS Glue mainly used for ETL operations team, data extraction, transformation, and loading. Using AWS Glue, we connect different sources, we extract the data, we apply transformations, and load the data into target. So source may be file system, source may be S3, source may be any data warehouse, target may be S3, target may be any data warehouse. So to perform ETL operations, we use AWS Glue, especially to perform data warehousing and analytics. Nowadays, you are seeing these reporting tools like Power BI, Tableau, QuickSight, and machine learning people and artificial intelligence people. They are going to connect data warehouse. They are going to read data from data warehouse. Data warehouses like Amazon Redshift and Snowflake contain huge volumes of data sets. So instead of applying analytic operations on huge volumes of data sets, because let's say Power BI, they want to display current day data. Let's say warehouse contain last 10 years of data. Instead of waiting to process on 10 years data, they want only, let's say, Ugadi related. Let's say coming, Christmas is coming. Let's say every Christmas last 10 years, what is happened? We want to know. So instead of sending to process 10 years data, we want only Christmas data. That kind of analytics on warehouse we can perform using AWS Glue. Then you can store the result like Christmas results only. Then our reporting tools, instead of pointing 10 years data, they point to this processed data, they can represent easily. So on data warehouse, if you want to perform any analytics, then we go with these kind of AWS Glue kind of technologies because these are distributed parallel processing, serverless computing, and it can process any volume size of data in parallel and distributed manner. Backend, it uses Spark technology. Okay. And other one, data lake management. Other important one, data lake management. My client want use S3, S3, S3. Let's say various sources, source 1 to source n, source 1 to source n. They want to extract this data. They want to load it into raw layer, raw layer. So use glue, connect different sources, load the data into raw layer. Then, then they want to do basic analysis on raw data. They want to do basic analysis on raw data like data count and basic validations like data type checks and string formatting and uh, date column format to change, such kind of basic analysis, and they want to store it in the branch layer. On this branch layer, they want to perform some basic filter operations and they want to move it into silver layer. On this, they want to apply transformations And finally, they want to store it into gold layer. These kind of data lake maintenance they want to do. Then each layer you can apply glue jobs, glue jobs, and glue job. Then you can organize in data lake. These kind of use cases also we are going to we are uh, going to use AWS Glue. And next important one, real time and batch processing. Real time and batch processing. Here, Tim, using Glue, you can implement streaming called real time and batch processing. Batch processing using Glue. Using Glue, you can implement streaming and batch processing. Batch processing. But it is never recommended to go for this streaming using Glue. It is recommended to implement batch processing. Streaming process recommended Kinesis service. Kinesis service. Then use Kinesis service. Use Kinesis service for streaming operation. Streaming operation. You can take streaming data using Kinesis service. Once it prepares that batch, right? On this batch data, go with batch analytics using Glue. This Kinesis Glue kind of implementation is recommended. Glue having real-time means streaming, batch processing. It is never recommended for streaming. It is recommended for batch processing. So for streaming purpose, our AWS providing powerful service called Kinesis. Powerful service called Kinesis. It is specialized only for streaming operation. So go with that Kinesis for streaming. Once it generated batch data, go with Glue for analysis purpose on batch data or batch processing. From beginning of Glue, I'm saying Glue meant for not small data. It is meant for processing huge volumes of datasets in a distributed and parallel manner. In streaming, uh, for every second or 5 seconds or 10 seconds, we will configure. You may get small pieces of data, right? So for such kind of requirement, go with the specialized service called Kinesis. Okay, it has a streaming feature, but don't go for streaming for AWS Glue. It supports both streaming and batch processing and data ingestion across multiple sources. You can connect to different sources. Let me show AWS Glue. Let me open AWS Glue. Let me create one ETL job. I'm not going to create complete job. Just for sources, I'm going to show. Just click on Visual ETL. Okay. Let me see sources. Sources. See, these are different sources. Glue catalog, S3. You can take source from Kinesis, Apache Kafka, relational databases, Redshift, MySQL, PostgreSQL, Oracle, Microsoft SQL Server, DynamoDB, Snowflake, BigQuery, Teradata, Amazon OpenSearch, Vertica, Azure SQL. SAP HANA, Azure Cosmos, MongoDB, and Adobe Analytics. See multiple sources. See multiple sources. Facebook ads. See, these are different sources. It's supporting various sources. So you can use AWS Glue for data ingestion purpose for connecting different sources, load the data into your target data store. It's supporting multiple sources. Next one thing. Glue also can be integrated with these monitoring alarm systems. Let's say my cloud watch contained logs with multiple technologies. Let's say multiple jobs configured, then you can track that and monitor that, and you can apply apply processing. You can implement monitoring and alerting using AWS Glue built-in monitoring tools. Track job execution and performance. We can integrate with the CloudWatch, SNS, and different notification service. If your job, let's say you written ETL job using AWS Glue, you can integrate with the CloudWatch. You can write log into CloudWatch. You can integrate with SNS so that if job is completed, you can send a notification. And you want to schedule Glue jobs, we can use Glue service also. We have different scheduling technologies like Lambda, step functions, but you have only Glue jobs. Then you know you no need other supported technologies. Let's say you have 10 Glue jobs. Go with the scheduling with Glue only. Yeah, uh, next one, it is a serverless computing. So if you want to reduce cost compared to fixed cluster of PySpark, fixed cluster of EMR, let's say your existing applications running a fixed cluster of Spark cluster or fixed cluster of EMR, we can avoid that one. We can convert those applications into AWS Glue. You can reduce cost. You can migrate those applications with Glue, then you can reduce cost. Okay, so these kind of implementations we go for AWS Glue team. Yeah, now let's understand very important component concept in master AWS Glue is components of AWS Glue. So main components AWS Glue data catalog, crawler, ETL engine, and scheduling system, and Glue workflows, Glue Studio, and AWS Glue Data Brew. These are main important components of it. First, let's start understanding these components of it. First, let's start understanding AWS Glue Studio. AWS Glue Studio. Let's say this is my AWS Glue Studio. Glue Studio, Studio. It providing it providing to develop a Glue applications using drag, drag and drop, drag and drop. let me show Glue Studio. This is my AWS Glue Studio. I can select a visual detail, then you can select S3. You can select S3. You can select a transformation. You can select a join. Then you can select a target. Let's say target is again Redshift. Such kind of drag and drop. Then once you save this program one, then if you click on save, then you can see script. Yeah, we have to provide additional operations. Then it will generate a PySpark code. Okay. You can Blue Studio provides for writing Glue applications too. First important one is Glue Studio. Glue Studio. Okay. Once you develop, let's say, next important one, Glue Data Catalog. So it provides central repository in Glue. It provides central repository in Glue. It holds meta information of your input source. Your input source. Let's say Glue data catalog. Glue data catalog. Here, source 1 is S3. Source 1 is S3. Source 2 is MySQL. Source 3 is SAP HANA. SAP HANA. So for all sources, we are connecting and we are creating a crawler. We are creating a crawler. We are connecting these sources. We are connecting these sources. We are storing information into our location. In Glue data catalog, we are creating database. Under database, we are creating table for each source. Table 1 for source 1. Table 2 for source 2. Table 3 for source 3. This table contains metadata information. Metadata information means where your data is presented, source location and source path. Next one, column names, data types. So we will store meta information. For that storing meta information, we are going to use crawler. Crawler in AWS connects to input source and reads the data and identify column names, and it identifies data types. It identifies data types, and it stores that information into Glue data catalog. So while writing Glue application, you can connect to this data catalog. You no need to write the definition here. You can directly read these sources details here. Okay. Next one, ETL engine. Let's say you performed drag and drop. Then you clicked on save button. Once you provided all properties, this one is going to generate a PySpark script for you. It will generate a PySpark code. It will generate what? PySpark code, optimized code, ETL script. You can select a Scala language. By default, it is Python. Default language is Python. That's why it will generate PySpark code. So clear, right? This job scheduling, ETL engine purpose, crawler purpose. So what crawler is doing? It connecting input sources and storing that meta information into Glue data catalog. ETL engine, once you save job, what it is doing? It is generating a PySpark code by default. If you select a Scala language, then it will generate a Spark and Scala code. Job scheduling system can be used to schedule your ETL job. I want to define workflow. I have multiple Glue ETL jobs. I want to define a workflow. This job executes first. This job executes next. This job executes next. You have only ETL jobs, then you can define workflow using AWS Glue workflow management. If you have multiple other AWS Glue jobs like Athena, Kinesis, then go with AWS step functions. AWS Glue workflow only for AWS Glue jobs. And AWS Glue data brew for self preparation of data. It is a self-service for data preparation tool for data cleaning and data transformation, and it provides built-in 250 transformations for formatting, deduplication, enrichment. You can easily integrate with tools like QuickSight and Tableau. So these are different important components to it. Yeah, let's start understanding AWS Glue terminology team. In our Glue application development, we are going to use this terminology in all our programs. First one, classifier, very, very important. Someone in the beginning, they asked, you may have CSV file. Inside a CSV file, you may use comma delimiter, someone may use hash delimiter, someone may use tab separator, someone may use different delimiter for columns data. Yeah, here there is one important concept called classifier. AWS Glue providing built-in classifiers. CSV a separate classifier, JSON separate classifier, XML for every file format it is providing a separate classifier. So we give a source, right? Whenever you give a source for storing metadata information, we select a crawler. Let me show crawler. Uh, let's go here. We have a crawler. In crawler, we create a crawler. Create a crawler. Then here we give a X something and click on next button. Let's say here we select a input source. Let's say I am selecting file from this location. Let's say I'm selecting file from this location. See, I'm selecting CSV file. I choose it. Whenever I choose this CSV file, whenever we choose CSV file, let's select uh, this S3 demo. That's it. Whenever you select this folder, it is saying crawl all subfolders. Okay, these are all. Let's select a file. Then see here you can see custom classifier. By default, assume your CSV file in CSV standard format. Means column is a default delimiter for all columns. All columns. Then you no need this custom classifier. Let's say your file contain uh, tab space as a delimiter or pipe as a delimiter, hash as a delimiter. Click on this custom classifier. Then select select add new classifier. Here we will define classifier for our file format XML, CSV, JSON. Let's say my input file is cell. Then here what kind of delimiter you have. You can select all delimiters. If it is other, you can select other, mention your classifier. So here classifier, default classifier follows default file format rules. If your file contain different format, create a custom classifier, specify your delimiter type in that. Okay, next one, AWS Glue Data Catalog. AWS Glue Data Catalog stores meta information. Meta information. Where is your input file path? Second one, uh, column name inside that file and data type of that file. It stores that meta information. Next one, very important one, connection. Connection. Let's say, let's say your source is RDBMS, RDBMS, RDBMS. Your source is RDBMS. Okay. You want to read RDBMS table. Then you need JDBC connection details, right? So that JDBC connection we can create using this connection concept. Any JDBC connection creatable or readable. You can create a connection and you can read from any JDBC connectable resources using Glue. Let's say you have in other cloud, you may have RDBMS setup, or you may have your physical or on-premise database. Then you can use create a connection. You can provide connection details. You can connect to that source. You can ingest data into your target location. But you want to create a connection, you want to store meta information first. Then you use this concept called connection. Next one, database. Database. In Glue Data Catalog, okay, you are storing multiple projects. So for every project, we create a database. Let's say ICICI DB to store all ICICI database related, ICICI account related. Then another database, HDFC, not HDFC, HDFC only, right? HDFC underscore DB. Like this, you can create a database and that client related tables you can store. In AWS Glue, we create a database for every project. That project related sources, meta information we store. ICICI, they having 10 sources. All these 10 sources related, we are storing into this database. And HDFC having 20 sources. All these 20 sources, tables, meta information we are storing into HDFC DB. Instead of uh, avoiding duplicateness and avoiding names segregation, names to maintain name segregations separately for every client, we create a database in AWS Glue Data Catalog. And very important one terminology is crawler. To connect with every source to get meta information, we use concept called crawler. Okay, these are very important terminology. Next important terminology, data store, data source, data target. First, data source. In Glue job, we just to drag source, right? That is data source. And we just to drag target, right? That is data target. Terminology is data source, data target. And data store means it's a location where your data is going to store. Okay. And next very, very important point is dynamic frame. In Spark, we discussed data frame. Yes or no? We discussed data frame. What is data frame? It is a structured format. It is a structured format. On this, we can apply the Excel queries. Yes or no? On top of Spark data frame, they developed dynamic data frame to support these AWS terminology. On data frame, AWS Glue developed dynamic data frame. It is also structured format to support AWS Glue. And finally, once you save your program, it will generate a Python code, right? That Python code, we call it as script. Once we save program, once we save that Glue ETL script, ETL job, then it will save a file in either Python or Scala. That program, we call it as script. Now let's start understanding job. This is my ETL script. This is one job. And we have another ETL script. That is another job. Every ETL script, we call it as job. We can configure that job using any orchestration tool. Inbuilt AWS Glue having scheduling plus workflow. Using step functions, we can define workflow. Using Apache Airflow, we can define workflow and scheduling. So every ETL script, we can call it as a job. And next one, table. Very, very important one, table. So what is table? A table contain input path location and column name and data type and type of that file, whether it is CSV, Parquet, etc. Okay, clear writing? So these are the terminologies we use multiple times in our Glue application development. Okay, yeah, yeah. As part of master AWS Glue, let's understand AWS Glue Data Catalog introduction. Let's say this is my AWS Glue. This is my AWS Glue. Here, first we create a database. Yes, sir. Inside a Glue, we create a database. Let's say this database is for ICI. This database is for HDFS. No, not HDFS. Bank name HDFS is a Hadoop distributed file system. HDFC, not HDFS. HDFC Bank. Let's say this database is for HDFC Bank. So these are different sources of ICICI Bank. Let's say they have S3, they have AWS RDS, AWS RDS, they have AWS DynamoDB, etc., etc. These are different sources. So using crawler, we can create a crawler and we can, let's say S3, S3, we have CSV file. S3, we have a CSV file. Then we can create a crawler. We can create a crawler. It uses built-in classifier, CSV classifier, because this file following comma as a delimiter, comma as a delimiter. Let's say there is another file under S3, another file under S3. This is also CSV, but here they used hash as a delimiter. Then we can use custom classifier. In this custom classifier, we can say my input file contain hash as a delimiter. Then we can attach this to crawler. Then it reads this file and stores in a table information. Let's say my file presented in AWS RDS. You can directly connect. My file contained in Redshift. You can directly connect. My data presented in DynamoDB. You can connect. Let's say ICICI Bank, they have Oracle database, Oracle database, Oracle database. Okay, this is on-premise. Let's say Hyderabad, sorry, in Hyderabad, they have data center. You may see a ICICI Bank tower in near to Wipro Circle in Hyderabad. Assume there they have a data center. They are managing their business details. They are storing into Assume here. Here you can create a connection. You can create a JDBC connection. You can give to crawler. In this JDBC connection, you can provide details of your database. Then this crawler using JDBC, it will connect here and stores metadata information of that table. Let's say I have SAP HANA. My ICICI Bank, storing data into SAP HANA ERP system. Then you can create a connection to SAP HANA using JDBC. You can connect. You can get that information. You can store into particular table. Clear? Yeah. Yeah. Let's start in. As part of master AWS Glue, let's start discussing practical example. In this practical example, we are going to see how to create a database table in AWS Glue data catalog using AWS Glue crawler. Okay. First, we are going to create a AWS S3 bucket. Then we are going to create a folder inside a bucket. Then we are going to upload a file into AWS S3 bucket first. And then later we are going to create a database. Let's say database name Akkem Sreenivas underscore DB. You can create any name. Okay, I'm going to create a database. Then I'm going to create a IAM role to access S3 bucket, and I'm going to attach this IAM role to crawler. While creating crawler, we can use option to create IAM role, or you can create IAM role first, then you can assign policy to IAM role, then you can attach IAM role to crawler. And once crawler is created to point S3 bucket, then we will run crawler. Then it is going to create a table inside this database. Okay, let's see practically. So open any web browser. I am opening Google Chrome and log in AWS Cloud account. I already logged into my account. Okay, so navigate S3. So here in recently visited, I am seeing S3. In your case, you may not. If you already visited, you are going to see. Otherwise, you can search in search bar. You can open S3 in new tab. Okay, I am going to create a bucket here. So there are multiple buckets. Okay, but I'm creating a separate bucket for us. So create a bucket. Bucket name I'm creating Akkem Sreenivas underscore blue. Okay, and give a public access. Then click on I acknowledge. Then click on create a bucket. Okay, this name already existed. So Akkem underscore Sreenivas underscore blue underscore sorry Akkem underscore Sreenivas underscore glue. Let me create this one. This is also, yeah, first one. This bucket name contains invalid characters. So here we have to give hyphen t, not underscore. Bucket name, we have to give hyphen. Let's create this one. Create a bucket. Bucket is creating. Bucket is created. Akkem Sreenivas hyphen glue. Okay. Now, under this, I want to place file. So file I want to place is employee file. Let's say I am creating one folder. Folder name is employees. Create employees folder. Then in this folder, upload a file. So for all my glue practice, what I did is I see under C drive data sets. In this you can see glue. In this you can see glue. Here I have different files. I am going to upload this employees file. Okay, let me load this employee file. So go to S3. Here you can click on upload, or you can just drag this file. You can just go to employees folder, go to here, just drag this file and click on upload. File is uploaded successfully. Okay, then this first step was completed successfully. Now create a database. Create a database. So to create this database in AWS Glue Data Catalog, open a service called Glue. Open this service in new tab. New tab. Okay. This is AWS Glue dashboard. In this AWS Glue data dashboard, you can see data catalog. Expand this one. In this data catalog, you can see databases. Okay, here you have option of add database. Database name I'm giving Akkem Sreenivas underscore DB. Database name you can use underscore also possible. Then I am creating a database. Okay, so database is created. Now click on this database. There are no tables, zero tables. Once we create a crawler to point to that input file location, that crawler going to read that file and identifies column names, identifies the data types, and creates a table in this location and stores that meta information. Where is input file location and what is the format of that input file? And then it stores column names. It stores data types based on the sample data. It will read crawler going to read sample data, identifies the data types, and stores that data types information into this table. Okay. So how we can create a crawler? This step 2 also completed. Now step 3 and step 4 I am doing in a single step, creating IAM role and creating table using crawler. These step 3 and step 4 I am doing in a single step. Let me go to AWS Glue dashboard. Left side under data catalog, you can see crawlers. Click on crawlers. Click on create crawler. Then give a crawler name. Let's say crawler name I'm giving employees underscore crawler. Okay. Then description is optional. I'm entering same name. Then click on next button. Here we have to select the source location. Click on add data source. Our source is S3, right? Crawler supporting multiple sources stream. So I'm selecting S3 source and here S3 path. Click on browse. Okay. Our file location is Akkem Sreenivas underscore glue. And in this select folder path, not file location. Select a folder path, then place cursor here, that red mark gone. Click on add S3 data source. Let me Yeah, crawler responsible to read S3 file location as well as it will read a file and it reads content of file, identifies column names and identifies data types and stores that meta information into table. Yeah, yes. It contain internal features to do these all activities. Yeah, one more important to note, Tim. One more important to note. Custom classifier is optional. Let me add here one important point to them. So we selected CSV file format. Yes or no? In usually CSV follows what format type? What is full form of CSV? Comma separated value. It means column names separated with column, value row, each value separated with comma, right? Second point is first row is header. So these are common rules of CSV, right? So, here this custom classifier is optional because here it uses same format. Default default classifier reads CSV file and identifies the first row as a header row. Next, remaining rows as value rows. Next one, each column separated with comma. Assume your CSV file column separated with different delimiter, maybe hash, maybe dollar, maybe something, tab space. Then we are going to create a custom classifier. We are going to specify what is the delimiter of your file. So if your file not following default features, if your file contain additional changes, we use this one. Later we are going to see because my CSV file. Let me open my CSV file. It is presented under C drive, under datasets, under AWS Glue. This is my file. This file, first row is header row and the columns are separated with comma. That's why I selected default delimiter one. Okay, next one. Click on next button and here we have to select IAM role. Third step and fourth step we are doing here. So here you can choose existed role or you can have a create a new IAM role. Here I'm creating IAM role. AWS Glue service role. I'm creating role is let's say Glue or give a name to AWS Glue service role. I'm giving uh, Akkem Sreenivas Glue. You can give any name. Usually we give valid name uh, based on the project we are working. We give corresponding name. Let's say ICICI loan module. We give like that. Let's create a role. Then now select a IAM role. Select a IAM role. Now go to IAM service. Go to IAM service. Go to IAM service. In this IAM, go to roles. What is our role name? AWS glue, AWS glue service role Akkem Sreenivas glue. Click on this role. Using crawler, what we are doing? We are connecting S3, right? We are reading, right? Then add a permission. Attach a policy. Which policy required? S3. Full access. Select this one. Click on add permission. Now now our blue crawler having a capability to perform any activity on S3. Now click on next button. Here select a database. Once it read file, once it finds complete metadata information, it is going to create a table, right? Where you want to create the table, select a database. I am selecting databases Akkem Sreenivasa DB. Then click on next button. Then click on create crawler. That's it. So third step, fourth step was completed. Now let's run crawler. Go to crawlers. So here click on run crawler. Then go to crawlers. Refresh this one. You can see employees crawler is running. Once this one is completed, we can see table. We can see metadata information about that table file location. Let's wait few seconds to complete this crawler running. Yeah, now you can see crawler succeeded successfully. Go to databases, click on this database. You can see employees. See database name and file location. File location and classifier is CSV. And you can click on this table. You can see column names, employee ID, employee name, is, department, and salary. Same column names, right? And data types. Yeah, yeah. Based on the sample data, it identified data types. If you're not satisfied, this data types and anything, you can click on edit schema. You can modify the corresponding data types. If you're not satisfied, we have an option of edit. Clear writing, how to create a database table in AWS Glue data catalog using AWS Glue crawler. Yeah, let's continue AWS Glue. In this, let's continue building a first Glue ETL job. In this ETL job, we are going to read only specific columns. I do not want all columns. I want specific columns from S3. Fine. So for that, we are writing uh, first glue application. Let's see here. Uh, go to AWS Glue. Go to AWS Glue and go to AWS Glue dashboard. Here you can see ETL jobs. Here you can see Visual ETL. So here, click on Visual ETL. First, give a job name. Give a job name. You can give .py and it is optional. You can just give any name, valid name. .py is optional. Okay. Next one. Go to job details. Here we need to attach IAM role because through the job we are going to read file. We need a read access. So IAM role, select IAM role. We created a IAM role just now. AWS Glue service role Akkem Sreenivas Glue. Select this role. Then click on save. Okay. Now go to visual. What is our requirement? We want to read S3 file. From that S3 file, we want to read few columns. Few columns. I do not want all columns. Okay. Click on this first symbol, first source. You can directly give S3 location. Already we have a metadata in Glue data catalog. Click on this Glue data catalog. Go to this Glue data catalog. Where is your file? Select a database. In that database, what is your table name? Employees. Okay, source we selected successfully. We selected successfully. We modified all the properties. Now go to plus symbol, transformation. In this transformation, we want to select a few fields, not all fields. We want to select a corresponding transformation. Let me see different transformations list. In this, we have select fields transformation. Click on select fields. Once you click on this select field, click on this select field. Okay, name, you can give any name. Okay, here, what are columns I want? My downstream is expecting employee ID, employee name, salary. So employee ID, employee name, and salary. Okay, now, now click on plus symbol and target. Click on target and where you want to place this data. Again, target also my S3, S3 location. Select S3 where you want to store this data. So go to S3 location. Under this glue, Akkem Sreenivas glue, I want to create a folder. Folder name is output, output. Okay. Under output, I want to store the data. So go to this glue crawler, sorry, glue crawler, select the file, select the target, and here see the format. So S3, and here file format, output, what format you are expecting. Usually output format we store in the Parquet format. Let's say this time I'm choosing output is JSON format. Then select the target location. Click on browse. Click on browse. In this, let's say Akkem Sreenivasa, Akkem Sreenivasa glue. In this output, go to here. Under output, here create one more folder. Let's say employees, employees, employees output. Then go to my visual ETL, click on output. Here, select this folder, click on choose. Then finally, click on save button. Okay. Then you can see script location. It is generated. It is generated by Spark code for you. You did complete graphical representation, dragging source, dragging filter, dragging target. We modified corresponding changes parameters or properties. Then it is generated by Spark code. Go to job details. See here language, language, default language is Python. Because of this, it is generated by Spark code. If you choose language Scala, it will generate Spark and Scala code. Other than that, nothing. You do visual, then go to job, whatever the language you want, select the language. I want a Python 3. Then click on save. Then you can go here, you can see script file in that format. Okay, we have successfully created a job. Click on run button. Click on run button. Yeah, go to runs. Then job is started. You can see job is running. Let's wait a few seconds. And if you see status is success, then your job is success. If anything failed, you can see logs. You can see the log information if it is failed. Later, if any job is failed, we are going to see logs. We are going to find the corresponding error message here. Later, we are going to see this is simple job. Hope it is success. It is succeeded. Now go to output location and verify job output. Go to S3 in this output location, in this output under employees, you can see JSON format. Click on this file and download this file. Go to this file location and open this file. So we are seeing in a snappy format. Let me go to here, remove this one. Okay, let's delete this one. Here, go to once again, go to our ETL jar. Okay, let's select this file. Let's delete this file and type permanently delete. Okay, go to here, delete. Go to our ETL jar. Go to visual interface. Go to target. See, snappy format. See, format JSON only, but we selected compression type snappy. Means it compressed in the snappy format. That's why we didn't see actual data. Then select none. Compression format none means actual JSON format. Then click on save. Then run glue job. Once again go to runs. Select latest run. Let's wait a few more seconds. Yeah, let's refresh. Can see it's still running. Let's wait a few more seconds. So now AWS Glue crawler is succeeded. Go to, sorry, not crawler. Our Glue job is succeeded. Go to our S3 location, then refresh, select this file, click on uh, download, go to file location, then right click on this one, open with notepad, then click on this one. You can see previously we selected compress format. That's why we see output in compression format. Uh, Now recent run we selected none. That's why it is stored in actual format. Okay. Yeah. Yeah. Let's continue, team. As part of master AWS Glue, we are discussing different examples. Okay. So in this, we are going to see one example called renaming columns. Renaming columns. Let's say we already having a database database with the table. Okay. We have already uh, having a data, but I want to rename columns. This is usual requirement. So in our target, we have already data uh, with our complete source data. Later, our client requested us to rename columns. So we use rename columns transformation, rename columns. We have an option called transformation called rename. Using that, we can rename a columns. So let me show a function here. First, we create a data frame from our uh, glue context. Then here we have a column with the column renamed. With the column renamed, we can pass a old column name. We can pass a new column name. Before that, let me open AWS Glue. Let me open AWS Glue. Yeah, I am opening AWS Glue. In this AWS Glue, let's open Glue catalog. In this, let's open a table. So this is employees table. In this employees table, see, column name is employee ID, name, age, department, and salary. Department and salary. Requirement is change this employee ID to EMP ID, name to full name, salary to monthly income. Okay. So to implement this one, first let's open AWS Glue new Visual ETL job. So click on Visual ETL and here create a ETL job. Create a ETL job. Then here give a name. I'm giving name is rename columns ETL dot py. Okay. Next one. Go to job details. Select IAM. Select a IAM role. Then click on save. Go to script. Go to script. Just remove this one. Okay. Uh, Before that, let me open a duplicate tab. Okay. So here my Glue database catalog name is Sreenivasa underscore. Let me go to catalog databases. My database name is Sreenivasa underscore DB. Okay. Let me rename here. Okay. Yeah. Take the script. Go to your Visual ETL. Visual ETL. So Visual ETL, we select drag and drop, right? Instead, click on script, click on edit script, click on confirm, then select this one, remove, place your script. Observe here, first all imports, all imports. Next one, creating a data frame from Glue context. Glue context. In Glue context, we have a Akkem Sreenivas underscore DB. Table name is employees. Employees. We are creating data frame from Glue data catalog. This Glue data catalog pointed to particular S3 file. Then I am converting Glue data frame to PySpark data frame. Then in PySpark data frame, we have a with column renamed, old column name, new column name. Again with column renamed, old column name, new column name. Dot with column renamed, old column name and new column name. Then finally, I am converting PySpark data frame to dynamic data frame. Then I am implementing write dynamic frame. I am saving where? Inside this S3 location. Let's say for all my S3, let me create a S3 folder. So here, let's see, we have created bucket for our glue, Akkem Sreenivas -glue. This is my S3 bucket name. Okay, let me take this bucket name. Let's change this bucket name. Bucket name is this one. Okay, and here also Let's change bucket name. Okay. Now let's observe here. Go to AWS script. Then under this bucket, there is a folder called outputs. So it is going to close here. Let me rename this one. Instead of again creating one more, let's say, yeah, let me create a folder called outputs. Under outputs, this is the folder, employee columns renamed. In this, it is going to create a output file format is file format. Here you can see Parquet file format. Then compression type is snappy compression. Okay. Then click on save. Then click on run button. Go to your runs. You can see run is started. It will take a few seconds time to complete your ETL job. Once it is completed, here in S3, you are going to see a folder called outputs. In that outputs, you are going to see a folder called employee columns renamed. Let's wait a few seconds. Here glue job is running. Yes, you can see execution is succeeded. Go to S3 location, refresh S3 bucket. You can see folder called outputs. Under folder, you can see employee columns rename folder. In this, it is generated a Parquet file. Select a Parquet file, and if you want to know column names are renamed or not, select a Parquet file, click on actions and click on, or you can see download. It is downloaded. Let's go this file. Let's open this Parquet format. You may not understand this Parquet file format. Okay. If you want to know records in Parquet format, you can open any online Parquet viewer. Let's say uh, Parquet viewer online. Let's click on any one Parquet viewer. Select a tool, select a file. Let's say under downloads, we have this file. Click on this one. Then you can see record details. Employee underscore ID renamed with employee ID. Name is replaced with full name, and salary is replaced with monthly income. So column names are renamed successfully. Clear, right? How to perform renaming columns using AWS Glue job? Yeah, yeah. Let's start in. Let's continue. Master AWS Glue. In this, we are going to see filter data transformation. This is one of the most usual requirement today. Example, I have a sales data, and in that I want to let's say I want to particular product data. I do not want all products. Then we can use a filter condition. Next one, I want to filter based on salaries. I want to filter based on gender category. I want to filter based on country. I want to filter based on particular city. So filter transformation is usual transformation in ETL jobs. Let's see how we can implement filter transformation. Okay. In our S3, we have employees file. For that, we created a blue catalog table definition, and we have a column called department. Department, I want to filter only IT department records. Let me open previous Parquet viewer. Okay, let me open here. You can see in this Parquet viewer, there is a column department. Here we can see IT department, one, two, three, three. So if I apply this filter operation for IT, IT, final output of Parquet file should contain only IT department data. Okay. So for that one, I am implementing filter data transformation using AWS Glue. Let's go to AWS Glue. Let's go to ETL job. ETL job. Let's click on ETL job. Click on Visual ETL. Then give a job name. Filter ETL. Filter ETL job dot py. Then go to job details. Add IAM role. Add IAM role. Then click on Save button. Then go to Script. Click on Edit Script. Click on Confirm. Then remove the script. Just paste the script file in. See here, this is script logic. See here, I am adding the script logic. Only I am adding this logic. Next one, I am going to take remaining part from previous script. Go to Visual ETL and Visual ETL jobs. Go to this rename column. Until data frame creation, this part, just copy it from this, just paste here. So from data frame creation, we are writing logic. Okay, see here, we are connecting this database, we are reading this table, and we created a dynamic data frame. And here we are using filter dot apply. Filter dot apply. We are passing our dynamic data frame name. Here I am writing lambda function. In this lambda function, every row I am checking IT department. So I'm going to create a new data frame with all IT department records. Then finally, I am going to write output into this S3 location. S3 location, employee filtered folder. Okay, let's click on save button. Let's click on run button. Okay. And then you can see go to runs, go to runs. You can see run is started. If there are no errors, it is going to finish. Let's wait a few seconds to complete this one. Yeah, job is succeeded. And let's go S3 location and let's go to outputs. Let's refresh. See, uh, employee filtered. Then select this one. Before that, let me delete this old Parquet file. Let me download this latest Parquet file, filtered Parquet file. Once again, go to filtered one. Let's click on uh, edit, or let's say uh, back. Then once again, upload a new file, select a new file, then click on upload. Then you can see only IT department records. Let's go another Parquet viewer because you exceeded daily uploads. Go to another Parquet viewer online link. Then click on another Parquet viewer. Let's go other one. Then select upload. Select a Parquet file. Then you can see all IT records. Clear writing. So we got only department IT. Yeah, let's continue master AWS glue. In this, let's discuss a remove duplicates transformation team. Usually, our input source may contain duplicate records. Duplicate records. So we may get this usual requirement team. So before persisting this data into target location, before persisting this data into target, using glue, first remove duplicates, and then finally persist output into target. Okay, using AWS glue, we delete all duplicate records, row by row comparison, row by row comparison. Let's say we have 1 billion records, or we have multiple records. If we take other technology, it may take long time to process row by row comparison. That's what we are going for this AWS glue to perform fast comparison. So it uses parallel and distributed computing so that it compare row by row. It compare any number of rows parallelly. That's why you are going to get a response very faster. Let's see how we can implement this uh, implementation. Go to AWS Glue. Okay. So go to AWS Glue editor. Go to ETL jobs. Okay. Click on Visual ETL. Then give a title to this one. Let's say remove duplicates ETL job. Remove duplicate ETL job.py. Then go to job details and add IAM role. Then click on save button. Go to script and click on edit the script. Click on confirm. Okay. Just take your program. Take your program. So first you need to add these transformation details within this job, okay. See here, move this import from here to imports location. You can use import anywhere, but recommended use all import as a first. Then here, see, we are connecting this database. We are connecting this employees to table. Employees to table container duplicates. Let's go my input location. Let me go to C drive. Let me go to datasets. Let me go to AWS Glue. Here, let me take one employees to file. In this employees to file, we have duplicates. 101 repeated 3 times, 102 repeated 3 times, 103 repeated 2 times, 104 repeated 3 times, 105 repeated 3 times. My requirement is I want to delete all these duplicate records. So first what I am going to do, in S3 location, in my buckets, S3 glue, here under I am creating one folder called employees2, then create a folder. In this folder, I am uploading my file, local file. I am uploading this local file into S3 location. Okay. Then click on close. Go to Glue data catalog. Go to crawler and create a crawler. Then crawler name employees2 underscore crawler. Then click on next button. Add a data source. Select a S3 file location and select this AWS Glue and select employees2 folder. Okay. Then click on choose. Then click on add data source. Click on next button. Select a IAM role. Then click on next button. Then select a database. Then click on next button. Then click on create a crawler. Then click on run crawler. Go to crawlers. Refresh. You are going to see a new crawler. It is running and it is going to connect your S3 file and identifies column names, identifies data types, and persist that meta information into Glue data catalog. Let's wait to complete this one. Yeah. So crawler is completed, almost completed. Go to AWS Glue, go to uh, tables. You can see table called employees to. Okay. Then go to your script. Okay. Then here we are pointing this table. Now table is existed. Then how we are dropping duplicates? See, in PySpark, we have a drop duplicates transformation. You just give drop duplicates, then it will delete all duplicates. It will compare row by row. If same row is replicated in input file, it will delete. Okay. Then finally, we are writing output into this bucket employee drop duplicates folder. with Parquet format with snappy compression. Let me save this program. Let's run this program. Go to runs. Let's wait a few seconds to complete this one. If there are no errors, then it will status become succeeded. Once it is succeeded, then we are going to verify in our glue under glue outputs. Under outputs, it is going to create a folder called employee and hyphen duplicates, removed duplicates with this name. Yeah, let's wait a few more seconds to complete glue job thing. Yeah. So observe here, we got error saying syntax error, invalid syntax, line number 7. Go to script and go to line number 7. Go to line number 7 from AWS Glue dynamic frame, import dynamic frame and see what is the error here. Go to runs. So syntax error, invalid syntax. Okay, okay, yeah, yeah. Let me modify this one, import. Okay, then save this one, rerun this job. Let me change in our code also. Let's save this one. Let me go to runs. So this pointed failed one, select running one. You can see running one logs. You can click on logs. You are going to see process of running your glue job. Click on run details. Click on run details. Let's wait for completing this glue job. Meanwhile, let's remove this generated file. Yeah, we already removed it. Let's wait a few seconds. Yeah. So job is succeeded. Go to S3 location, refresh. You can see folder called employees hyphen dropped hyphen duplicates. Click on this one. Select this Parquet file. Click on download. Okay. Go to Parquet viewer. Let's try to upload a new file. Click on this one. Then select this file. Click on viewer. Now you can see only original values. Earlier we seen with duplicates, but now you are seeing only unique values. Okay, clear writing? How to delete a drop duplicates? Yeah. Yeah. Let's continue AWS Glue team. As part of AWS Glue, we are discussing different examples. In this, let's continue joining datasets using join in AWS Glue. So in this, we are going to take a different datasets. One is employee data frame and other one is departments data frame. Let me open datasets. I am going to open datasets folder. Let's say datasets folder. Here AWS Glue. Here I have emp.csv file. Let me open. Okay. emp.csv file. And I am opening another folder department.csv. So these are department file. So if you see, we have 11, 12, 13, 14, 15 departments, and we have different employees. Let's say total 11 employee records. Okay. Yeah. Now what I'm doing, first I'm going to create tables using AWS Glue crawler. So for that, first I'm going to upload these files in S3 bucket. S3 bucket. Let's say I'm opening AWS S3. S3. In this, we have different buckets. Let's say here, Akkem Sreenivas glue. In this, I am creating two folders. One folder is EMP, and another folder is DEPT. I am creating another folder DEPT. Okay. Then under EMP folder, place EMP file. EMP file. Click on upload. Click on this one. Click on close. Under DEPT, upload department folder. Okay. Click on upload. Then create a glue crawler. So go to data catalog and click on crawlers. I'm opening a new tab. So create a crawler, emp underscore crawler. Then click on next button, add a data source, and I'm selecting S3 file. Under glue, we have emp folder. Select this one and click on add data source. Click on next button and select IAM role. Then click on next button, click on database, and then click on next button, and then click on create crawler and run crawler. Similar way, create another crawler. Let's say go to crawlers, create crawler and DEPT crawler, DEPT underscore crawler, and then click on next button, click on add data source, select a file, select a folder, and then select DEPT folder, then click on add S3 source, click on next button, then select IAM role, then click on next button, select a database, and then click on next button, then click on create crawler and then run crawler. Okay, then go to crawlers, refresh this crawlers. Okay, DEPT crawler is running and EMP crawler is succeeded. Meanwhile, go to AWS Glue and create a job ETL job, then give a job name. Job name is join datasets .py or join datasets ETL job, join datasets ETL job .py. Then go to job details and provide IAM role. Then click on save button and go to script file. Okay, click on edit script, click on confirm, then go to end of this commit, between this commit. Okay, let's take our code and here select these parameters, these properties. Observe here what kind of join operations we are performing. Let's see here. So first I am creating a data frame for employee data frame by pointing employee table in Akkem Sreenivas underscore DB. We have EMP table. So creating dynamic data frame from data catalog, created EMP data frame, converted into Spark data frame. Next one, created DEPT data frame by pointing blue data catalog, then converted into Spark data frame. Okay, now I am performing inner join, inner join, inner join, employee df dot join DEPT df on department number. Tell me, what is inner join? What is inner join? Okay, let me take this one as separate. Let's take this one. Yeah, tell me, what happens here? Department number and department number. So here 11, here we have 11. So total 4 records in EMP table of department level and 1 record in department table. So we get how many records here? We get 101, 101 Sreenivas 20,000 and male 11 IT Dev Hyderabad. So we are joining two tables. Two tables by using join condition called inner join, and we will get match records from both the tables, right? So we get in this way. One record is matched and another record is matched and another record is matched and this one also matched, right? So in this way, we get details. Next one. Another record is 12. 12 is matched. 12 is matched. Let's say instead of take this one, different color. 12 is matched. 12 is matched. Next one, 13. 13 is matched. Matched record. Next one, 12 also, sorry. So we have 12 again, 12 again. Next one, let's take 13th department. 13th department, 13th department, and 13th department. Next one, 14th department. Let's say there is no 14th department. So this will not come. Yes or no? So here we have 15th department. There is no 15th department in EMP table. In here we have 16th department. There is no 16th department table. Only 11, 12 in department data we will get. The giant means only matched records from the both tables, right? Handwriting. Okay. Next one. Next one we are implementing. Next one we are implementing left join. Left join. So first all match records from both tables. All match records from both tables. Left join. So left join. Left join. Match records. Match records. Match records. All match records. 13, 13, 11, 12, 13. Okay. All match records. Next one. Yes, yes. EMP2 to DEPT. Observe the code. So we are doing left to join, emp.df left join to DEPT. Next one, non-matched record of left table called this one, 16th. You will not get 15th, 14th and 15th, but you will get this 16th. But EMP department, we get empty records. Sorry, department, we get empty records. Yes or no? All matched records of both table. Non-matched record left table called EMP with empty records, empty columns of DEPT table for that non-matched record. Next one, right join. If we use right join, then tell me, right join means first one, all matched records from both the tables. 11, 12, 13, 11, 12, 12, 13. All matched records. Next one, non-matched records from right side table. Right side table. For these two rows, we get left side table empty values. Empty values. Yes or no? For this non-matched records from right side table, we will get but values of right table is empty because there is no values matched to right side table. If we use full outer join, what happens? First one inner join, next one right join, next one left join. Both these three combination output we will get in full outer join. All match records from both the tables, non-match records from left table, non-match records from right table. All the values. Okay, so we implemented this data set using here. So left to join, right to join, and first one inner join, next one left to join, right to join, and full outer join. Let me see here. Here, Akkem Sreenivas -glue. In this output folder, it is going to create a output files. Let's take save this one and then click on run button. Click on run button. Then go to runs and it is started. Let's wait a few seconds to complete this program. Here we got error. Dynamic frame is not defined. Okay, let me go here. I did not import this dynamic data frame team. So it's a mistake of import because I used imports from that one. That's why we got this error. Let me go script. Let's import all this. Then click on save and rerun. Go to runs. Select this run. So job is success. Go to S3 location and go to glue job. Then refresh. Go to outputs. Outputs. You can see. You can see. Uh, Line underscore inner. Okay. Next, go to here and join underscore left, join underscore right, and join underscore full. Let's first see join underscore inner. Let's download this file. Okay, open this file in any one of Parquet viewer. Parquet viewer online. Let's take this one. Let's take third one and select the file and go to downloads. Go to here downloads. Sorry, I saved in the form of CSV only. That's why uh, we are not able to see Parquet file. I saved in the format of CSV only. See, 12, 11, and 13. All match records. Next one. Next one. Let's see. Left to join. Go to left to join. Select this file. Download. Go to downloads. Open this file. See, match records 12, 11, and non-match record from EMP table. For department, there are no match records. Yes or no? Next one. Uh, Coming to right to join. Let's open right to join output. Right join. Download. Go to folder location. Let's open this file. See. So match records from both the tables. Okay. Both the tables. Non-match records of right side table, but no record matched in EMP table. No match records found in EMP table. Clear writing? Yeah. Yeah. Let's continue. In this session, we are going to see aggregate data using aggregate operations in AWS Glue as part of master AWS Glue. Let's continue another example, aggregating data using aggregate operations in AWS Glue team. Okay, so here we have DB. In this DB, we have employees table, and in this employee table, we are going to perform aggregate operations like total salary, sum, average, min, and max, and next one count. So we have 5 aggregate operations in SQL: count, sum, average, and min, and max. Okay, department wise, I want to perform department wise count, department wise salary, sum of salary, department wise average salary, department wise minimum salary, department wise maximum salary. Each department I want to count how many employees and what is total salary, what is average salary, what is the minimum salary in department, what is the maximum salary in department. Later, I may take decisions based on this output. Okay, let's start implementing this one tip, aggregate operations. So go to AWS Glue. First, log in as a root user in AWS Glue and open your Glue. Then click on ETL jobs. Then create a ETL job. Before that, let me see here. Select a region North Virginia because we created all Glue jobs in North Virginia. Okay, go to ETL jobs. You can see all ETL jobs. Now, let's create a ETL job. Then here, write your ETL job. So my ETL job name is aggregate data ETL. Aggregate data ETL job.py. So let's create a job. Now go to job details and assign a IAM role. Then click on save. Now go to script file. Then click on edit script. Yes, I want to edit the script. Then add your ETL job between the job commit. Okay, let me go to our code. So take this code. Yeah, let me take this entire code. Sometimes we may miss dynamic data frame. Instead, let's take this entire code. Let's add this entire code. See, first I'm creating data frame. First I'm creating a data frame to point to this employees table. We have created a crawler to crawl employee file in Glue data catalog, right? Then I am pointing this Glue data catalog. I am creating a data frame, okay, Glue data frame, and I am converting it as a Spark data frame. Then I am applying group by operation. I am passing one column. Let's say I have four groups. Four groups. It will create four departments. It will create a four groups. Four groups, and let's say let's say this one is 11th and 12th and 13th, 13th and 14th. 14th. Okay. And here all 11th department records, all 12th department records, all 13th department records, all 14th department records. 14th department records. Okay. Now, so this group by function of Spark creates records in this way. Then in this we have aggregate function. In this aggregate function, we can pass value count operation and which column you want to perform count. So I'm saying here there is a column called employee ID. Take that employee ID as a parameter, then count records. So it will return, let's say 10 records, 5 records, and let's say 20 records. Assume this one is 15 records. Assume. In this way, we have records. Next one, it will call average, and here we are passing salary column as input. Then it will take salary column, performs sum. Let's say all is file 2 lakh or 3 lakh, 3L and 2L. Let's say this one is 30L, this one is 20L. Like this, it will perform count. And then we are passing salary column as input to average function. Then we are asking to perform average. So here 3L by 10, you will get average. 5L by 3, you will get average. And 30L by 20, you will get average. So in this way, it will perform min value, max value, and additionally, see, we are using alias, alias, alias. For this result, for this result, column name, we are giving total salary, average salary, employee count, min salary, max salary. Alias function we are giving. Result we are creating one column. In that column we are storing result. Okay. And finally, we are converting our PySpark data frame to dynamic data frame. And finally, coalesce function we are using. Let me add one important point why I am adding coalesce function. Let me say, let me understand. I created data frame from file which is presented in S3, S3, S3. Then I created a data frame. I created a data frame. Assume this data frame created with three partitions, three partitions, three partitions. Assume it created with three partitions. So when I write this one, when I write this one, uh, in output path, in output path, in this location, what I'm doing, write dynamic data frame function I'm using, write dynamic data frame. So I'm saving into output location where I'm storing in sorry, in this output location. So my data frame having three partitions, right? It is going to create a three output files. In this output location, it will create a three output files. So I do not want to three output files. I want a single file. So we have repartition. There are two functions, repartition, repartition, and you can specify number of partitions and coalesce. You can use coalesce function or repartition function. Coalesce compared to repartition, coalesce is reduces lot of transformations in the background. It improves performance compared to repartition. You can use either repartition or coalesce to reduce number of partitions. Then finally, I'm saying I want only one partition. Combine all three partitions into one partition. So in output location, I will see only one file. Okay. Let me save this program. Save this program. Let me open S3 in another tab. Under AW Akkem Sreenivas glue. Here we have outputs folder. Outputs folder. In this outputs folder, you are going to see aggregate. What is the name? Uh, Name is aggregate. Aggregate output. Okay, let's click on run. Let's go to runs. Let's wait for a few seconds to complete this job. Let's wait a few seconds. Almost completed. Let's wait a few more seconds. Yeah, it is succeeded team. Let's go to S3 location. S3 location. Let's refresh. You can see aggregate output. In this, you can see the file. Let's click on this file. Let's click on download, and which format we uh, persisted this file. Go to script. We saved file in CSV format. Let's go to downloads location. Open a file. Okay. Let's open this file. Let's say notepad. See, each department wise count. HR department count is 3. And total salary, average salary, min salary, max salary. Department count, total salary, average salary, min salary, max salary. IT department, total count, mm, total salary, average salary, min salary, max salary. Clear writing? Yeah. Now let's continue master AWS Blue different examples too. In this, let's start discussing pivoting data in AWS Glue. Pivoting data in AWS Glue team. Let's see input and how we are going to pivot. So this is my input data team. Input data. If you see, I have a 12 records in this input file. My requirement. See here we have a column called year. We have a column called year, and we have departments, and we have employee ID and employee name and year. So if you see year, if you see 2022, how many times repeated? 1, 2, 3, 4, 5, 6, and 2023 repeated in 1, 2, 3, 4, 5, and 6. So my requirement here I have a 12 records, but I want to convert this 12 rows based on the year. If year I have 4 different years, I want 4 rows. If year only 2 years, then I want only 2 years. I want to convert based on the year column, the value presented in year column. Okay. So converting multiple rows into few rows based on particular column value. Based on the column value. If you want to convert your number of rows, then we use pivot function, pivot functionality. There is a function called pivot, and we pass column name. Sorry, we pass what? This one, group by year, pivot based on the department. See here, if you see department, department, see department values converted into columns. One important note to do. One important note. We have rows. We have rows. We have rows. In this rows, we have a column called department. Department. Whatever the column, it may be year, it may be column. It may be year column, it may be department column. In this column, we have values. In this column, we have values. V1, V2, V2, and again V1 and V4 or V3, and again V2. So total we have multiple values. I want to convert this as a column name. New column name. V1, V2, V3. So for this one, if you want to convert a row into a column value, a row value, you want to convert it as a column, then we are using pivot. Convert rows to column. Convert rows to column. We use pivot function. Let me implement this one. Pivot data ETL job.py. Then go to AWS Glue. Okay. Go to ETL jobs and create ETL job. Then give a name. Go to job details. Add IAM role. Then click on save button. Click on script. Edit a script. Take your this code. Okay. Then see, I am connecting employee salaries. Okay. So go to input location. Go to C drive. Go to datasets. Here, go to AWS Glue. In this, you can see employee salaries.csv file. Open this CSV file. Okay, you can see the CSV file. Okay, let me create a table for this one. So our requirement is I want to create EMP salaries. So first, what I'm doing, I'm opening new tab, duplicate tab. Then go to this one. Go to crawler, data catalog. Go to crawlers. Okay, and create a crawler. Give a crawler name, employees salary, employees underscore salaries underscore crawler. Then click on next button. Then add a data source. Before that, you need a data source. Go to AWS Glue and create a folder. Folder name employee salaries. Then click on create folder and go to employee salaries. Upload this file. Employee salaries file. Then click on upload. Click on close. Click on close. You can see employee salary. Go to crawler. Then add a data source. Select a file path. Go to AWS Glue and go to select employee salaries folder. Click on choose. Okay. click on Add S3 data source, click on Next button, select I am row, then click on Next button, choose database, then click on Next button and click on Create crawler. Okay, so crawler is created successfully. Then run crawler. Okay, go to crawlers, refresh. So employee underscore salaries underscore crawler is creating. Let's wait a few seconds to complete. Yeah, it is completed. Go to our script file, then save the script file, run the script file, go to runs and click on run button. Let's wait a few seconds to complete this chapter. Job is succeeded to. Let's go to S3 location. Let's go to AWS Glue bucket. Go to outputs folder and you can check pivot, pivoted underscore salary and see what is the output format. Go to script and see output format is CSV and go to S3 location, select the file, download the file, then open a folder, open a folder. Let's open this folder. See here, finance department and sum of salary, HR department, sum of salary, IT department, sum of salary, group by year, each year wise. Clear, right? Yeah, yeah. Let's start in. In this, we are going to start Master Amazon Athena. As part of Master Amazon Athena, let's start understanding what is Amazon Athena. What is Amazon Athena? Exactly. We have S3, we have S3. In S3, in S3, we can create buckets. We can create a bucket. Inside a bucket, we can create folders. Optionally, we can create folders. Inside a folder or inside a bucket, we can load files. Let's say file 1, file 1. So inside a bucket, load file city. So S3 supports unlimited storage, unlimited storage, unlimited storage. It is a storage service. It is storage service. It is storage service. If I want to, if I want to write some analytic operations on these files, we can use either Python or PySpark or AWS Blue or some other programmatic approaches to perform analytics on this data. Yes or no? It is a file and it is huge volumes of file. A bucket contains huge volumes of data. So if you use traditional technologies, it will take more time to process. That's why we apply we apply data engineering technologies to process this huge amounts of data sets. For that, we need a programmatic approach. Yes or no? So instead of writing programmatic approach on this data to perform analysis, instead of writing programmatic approach to perform data analysis on this file system, AWS given one special service called Athena. AWS given one special service called Athena. Using Athena, you can write data analysis using SQL queries. Using SQL queries. Okay. On top of S3 file system. On top of AWS S3 file system, you can write simple SQL queries. You need to run any programmatic. You can write whatever till now you know SQL knowledge, right? You can write that SQL using Athena on top of S3. Let's say S3 contains file systems. So Athena knows about this file system. So for that, it uses AWS Glue Data Catalog. AWS Glue Data Catalog. Let's say AWS Glue Catalog. AWS Glue Catalog contain AWS Glue Catalog. AWS Glue Catalog contain metadata. Metadata about this file. Metadata about this file. It contains table name, file location, and column name, and data type of each column. Data type of each column. So this meta information Glue contains this metadata information about this file. So whenever you write SQL, it reads this meta information and reads this file. Based on this metadata information, it reads this file. Okay. So using Athena, we can write pure SQL queries. Pure SQL queries. Amazon Athena is a serverless, interactive, query service. You no need to set up any mission to run Athena queries. AWS people give nice user interface where we can write SQL queries, on data presented on S3. No need to write any ETL code. No infrastructure is required. Just focus on writing SQL queries. Internally, it uses different technologies like a Presto, Rhino to process your SQL queries, to execute SQL queries on top of S3. It supports different file formats. It supports almost all file formats like CSV, JSON, Parquet, ORC, Avro. It supports different file formats, and it uses AWS Glue data catalog for metadata information. One more important point I'm going to add here is, let's say AWS Glue do not have your S3 file data, file meta information. Assume using Athena, you can create a table on top of S3. You can create a table on top of S3. Then that metadata information, whatever you use, create table on S3 file system using some definition, right? That definition is going to store it to AWS Glue data catalog. You can create directly without AWS Athena. You can also create definition or meta information using AWS Athena using create command. So it's very, very, very important service in AWS data engineering. And if you want to do any analytics on S3 file system, the best service in AWS is Amazon Athena. Here we are going to use pure, pure queries, SQL queries. We never use single line of programmatic approach. We use ANSI SQL. ANSI SQL is common for every database, every warehouse, right? Similar way, you can use the same SQL on Amazon Athena. Okay, you no need to know programmatic approach. If you know SQL, you can happily work on Amazon Athena. If you do not know SQL, learn SQL and SQL is very, very easy. Clear, right? What's Amazon Athena? Yeah. Let's continue master Amazon. In this, let's start understanding key features and use cases of Amazon Athena. First important one, Amazon Athena is a serverless. You no need set up any mission physically or virtually or out. You no need to set up anything. You need a AWS account. You need a AWS account. Let's say I have AWS account. I have AWS account. Here you can search Athena. You can search Athena. Let's open it. See, this is my Amazon Athena dashboard. Amazon Athena dashboard. Here you need to select query your data in Amazon SageMaker or query your data in Amazon Athena console. This one is recommended. And click on launch query editor. So this is Amazon Athena query editor or dashboard. Here we are going to write our pure SQL queries. Here we are going to write our pure SQL queries. SQL queries. So this is our Amazon Athena dashboard, and in this we have opened Amazon Athena query editor. Okay, yeah. Next point to do. Next important point to do. If you observe here, uh, it offers pay as you go basis. So what is pay as you go basis? First important point, it comes with free tier. It comes with free tier. What is the limitation? We are going to discuss in next topic. Next topic. Just understand, it supports pay as you go basis. Let's say you have data in S3. Let's say you have 1 GB data. You are writing SQL query. How much data you are scanning to apply this data analytics? You can pay only for that, and that too how much time it is taken. Based on the AWS people calculates pricing. So you no need separate infrastructure, and it approaches pay as you go. It applies pay as you go basis. So you no need a setup cluster with huge number of machines, right? You are using serverless architecture, and you are paying how much data you scanned, how much time it is taken to process. Based on that, AWS people calculates a pricing. And next important, it is fast start. So when we write query, uh, you no need a separate environment for start. You just click on submit, it will work, because you no need separate library to run this one. So they already set up everything. They are giving nice user interface where you are writing your queries, where you are writing your queries. So it is very fast. Whenever you submit, it will work. It will not take much time to set or load libraries. Next, very, very important one, it integrates with Glue, or it connects with Glue before processing queries on S3, because S3 contain complete file system data. So that file system related definition where we store inside a AWS Glue data catalog. So there are two approaches to create a metadata. One, using AWS Glue crawler. You can create a crawler. That crawler can connect S3 file system, reads S3 file system, identifies a header, reads sample data, identifies the data types, and stores that meta information into Glue data catalog. So one approach is Glue crawler. Second approach, in Athena, you can write direct create a table definition. So if you write a create a table definition, it is also stores that information into AWS Glue data catalog. And very, very important thing is supports giants. You may have multiple tables. You want to retrieve data from multiple tables. When data is in multiple tables, we write join operations. Yes, sir. Without a join, we cannot access data from multiple tables. So Athena supports join operations on multiple files or sources. And very, very importantly, federated queries. Query data in RDS, Redshift, or even JDBC. Along with S3, along with S3, it also supports query data in RDS, Redshift, or any JDBC supported one. With 99.9999%, we use Amazon Athena on S3 file system. Amazon Athena on S3 file system team. Okay, yeah. Let's continue master Amazon Athena. Let's start understanding how Amazon Athena works. Let's see high level architecture. So first data is presented in S3. S3. You may ask a question, how data comes into S3? Using data ingestion techniques. Using data ingestion techniques. Ingestion techniques. We will load the data into S3 or different applications loads the data into S3. There are multiple ways data comes into S3. First one, we have a bucket, optionally folder. Inside a folder, we have files. Star.csv, CSV files, or Avro files, ORC files, Parquet files, etc. So we load the data into S3. For our practice purpose, we are going to create a bucket. We are going to create a folder. We are going to load file manually for our practice purpose. So first, data is presented in S3. Data is presented in S3. Next one. Next one. We will create a metadata. We will create a metadata into AWS Glue Data Catalog. Glue AWS Glue Data Catalog. AWS Glue Data Catalog. Here we create a metadata. 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 Here we create a metadata. This metadata contains file location. File location. Okay. Comma. Column name. Comma. Data type. Data type. Comma. File format. File format. File format, etc. These are main important things. These are main important things. File location, column name, data type of column, file format. It contains this metadata information. Metadata information we will create using crawler, using Glue crawler. Glue crawler. Okay. One thing, we can create crawler. Crawler can reads S3 file, stores this metadata information, or inside Amazon Athena query editor. Inside Amazon Athena query editor, we can write create a table command. Create a table command. Table command by pointing this S3. Then this create a table command also stores metadata information. So first, schema in Glue Data Catalog. How schema is going to create in catalog? One, using crawler, or other, we create a table definition using Amazon Athena. So that plus Glue Data Catalog contain definition of this file. That's one. Query engine. Query engine. Amazon Athena contain query engine, query engine. Here we write SQL queries. Let's say I am writing SQL query, SQL query. Let's say select query. Whenever I clicked on run button, Amazon Athena query engine responsible for connecting this glue data catalog, understanding this definition, understanding this definition, and connects to your S3 location, process your query, and generates response. So query engine in Amazon Athena is responsible to process. Finally, output to S3. Output to S3. Here we are going to see inside query editor, we are going to see output, but this output, where it is going to store is, we will give a path of S3 location. Let's say we are going to create a separate bucket for our Athena outputs. Let's say Athena outputs. In this Athena outputs folder, we configure. So once I said query engine going to execute the query, right? It generate a result, right? That result, it is going to store it into S3 location, only result. Then you can see output of this result in Amazon Athena console. Amazon Athena console. Okay. So in this way, Amazon Athena works. Hope you understand these four important steps of Amazon Athena. First point, first point, why we are going for S3 bucket is it supports unlimited storage. There is no limit. There is no limit for S3. There is no limit for S3. Let's say I created folder for employee. Let's say I'm storing monthly data. Let's say last month one data, this month one file, today one file, tomorrow one file. Like that we can store all employee related same structured data into this location. You can store any size of data. There is no limit. Unlimited. Yes, yes. Yes. Usually, usually, usually we use S3 for storage of data. That's why we connect multiple sources, we store the data. S3 is reliable, it never fail. You can access this data. You no need separate backup mechanism for S3. S3 supports unlimited storage, 100% reliable and durable. And only one thing, if you want more reliability, you can configure multi-available zone. So sometimes, let's say, assume uh, we have uh, we have selected Mumbai region and we selected availability zone North Mumbai. Assume entire North Mumbai suffering with floods, earthquake, or some other natural disaster. Then that availability zone may not available. Then you can choose that to more reliable. You can select a multi-availability zone. So it never fail. It never fail. So, yeah. Yes. Let's start continuing Master Amazon Athena. Let's start understanding Amazon Athena pricing model. Using this Amazon Athena, you are writing SQL queries. Then we have discussed Amazon Athena is a serverless. No need to set up any server or no need to create any mission for running your queries, right? So, how Amazon people calculate pricing for their queries? Okay, let me discuss here. Let me discuss. Let's say, let's say, uh, we are writing queries in Athena. Athena. Let's say in this Athena, we are writing select query. Okay, and let's say star and table name is sales cells. Okay, here we have S3 bucket. We have S3 bucket. We have S3 bucket. Here, let's say bucket name sales bucket, and in this we have a sales folder. Sales folder. In this, let's say we have file one. Let's say file one. This file one, let's say it contains 1 GB data. 1 GB data. So let's say we are applying this select query on this data. Then how Amazon people calculate pricing for this one? How Amazon people calculate pricing for this one? First, your data size. Next one, how much time, how much time your query ran. To process this one, it may take fraction of seconds. Yes or no? So understand query execution. For $5 for 1 TB. $5 for 1 TB. So expect how much for your 1 GB data? Very, very, very minimum. Yes, sir. Let's say after again you are running this query. This time you have one more file. Let's say 10 GB data. New file, 10 GB data. So data ingestion team ingesting data into this location. Let's say daily they are ingesting. Daily they are ingesting data. At particular time, they are ingesting data into this location. Day by day, data is growing. One day 1 GB, 10 GB, 5 GB, 3 GB, 2 GB, 20 GB. Like that, data is growing. Data is growing. Data is growing. Not like anything into this sales location. Every day sales happening. If it is festival, more sales happens, then you are going to get a big file. Yes or no? If it is some special day, sales happens more, then you will get some more big file. So all the files you are storing into sales folder. So uh, whenever you write a query, how much data this query is scanning, based on that they calculate. For 1 TB, they are going to charge $5. Okay, and I said here it is going to connect blue data catalog, blue data catalog, blue data catalog for meta information. Okay, so first free 1 million per month, 1 million request. If you send this request for connecting this blue data catalog, right? How many times you're going to send? 1 million cards, 1 million times connections are free, requests are free a month. After that, they are going to charge based on the blue data catalog pricing. Next one thing, I want to reduce pricing. I want to reduce. Let's say this one contain 10 TB, 10 TB. I am writing queries like this. I am writing queries. Select star from sales where city, city equal to, city equal to Hyderabad, city equal to Hyderabad. Let's say in this 10 GB data, just 10 GB data is Hyderabad data. 10 GB data is Hyderabad data. But for this 10 GB, we are reading entire 10 GB data, 10 TB data. So your cost is too high. Then how can we reduce? We have a concept called partitioning. Partitioning. You can create a partitions, city-wise partitions. City-wise partition. Hyderabad one partition, Pune one partition, Bangalore one partition, Chennai one partition, Mumbai one partition, Noida one partition. Like that, you can create a multiple partitions. Multiple partitions, nothing but subfolders inside main folder. Subfolders inside a main folder. But while creating a table, you can give indication to Athena. Hey Athena, our S3 contain different partitions. So that so if you write these kind of operations, it will go directly to particular folder and reads the data instead of entire data so that you can reduce cost of Athena. Cost of Athena. And other approach to another way to reduce cost is along with the partitioning, we have different compression techniques, columnar techniques. If you store data in Parquet format, it is a columnar format, fast reading, fast processing. And we have compression techniques like Snappy and different compression techniques so that at a time we can read more data, compressed data, and compression instead of 10 GB, it will become a 1 GB. If you use compression techniques like Snappy, we have different compression techniques. So low level into do compression, then it reduce your data size so that you can reduce cost. First one, first one, actual data. To reduce cost, we use partition. To reduce more cost, we do compression. To reduce more cost, we use different format types like a columnar format called Parquet. So these are different techniques to reduce cost of Amazon Athena. For our simple queries, it is free. But when you work with real organizations like health sectors, banking sectors, finance sectors, their data is huge volumes. So they do these kind of different techniques to reduce the cost. Okay. Hope all of you understand Amazon Athena pricing model. Yeah, sure. Correct. You are 100% correct. Let's say, and yes, perfect, correct. Bucket. Inside a bucket, we create a folder. Let's say, sales folder. Inside a sales folder, we create a partitions, correct. Hyderabad one partition, one folder, HYD one folder, and in this we store dot bucket for reducing cost. Another, yes, correct. Here we use another folder, then here we use Chennai, correct. Let's say here we are writing create table. In create table, we can say in create a table, we can say this file, this sales data contain partitions. We give a information here while creating definition. While creating definition, we say our input location contain different partitions based on city column. We give a information to partition by column name. Column name. Correct. Same as our regular RDBMS style. Or same as our regular warehouse style. We provide a definition. That is different. This is different approach. Yeah. See, this is query engine, right? Query engine, right? This is already query engine. Instead of Glue, PySpark, we are using Athena for writing queries. Again, you want to go with the complex. To reduce complexity, we are coming to Athena. Whatever we do with Athena, we can do with Glue, Python, PySpark, everything. But those are programmatic approach. To reduce that one, we are coming to Athena. We are writing simple SQL queries. Again, you are asking to go that yes, you can do, you can do. You can apply all your SQL skill set. Already optimization, we are creating partitioning. We are creating partitioning and we are using compression techniques. We are using compression techniques and we are also using columnar format like Parquet format. Then it is already giving a best performance for you. Still, you want to apply any SQL techniques to optimize? Yes, you can write a SQL techniques to optimize query execution time. Apply your all SQL skill set. Yeah, that's why it is very good feature in AWS cloud team. Maybe other clouds maybe have it, but in AWS for doing data analytics, we usually go with Athena on top of S3. No need to go, no need to write any programmatic approach. You can directly write SQL queries. Yeah, one of our friends said filter condition city equal to Hyderabad and city equal to Bangalore. Two partitions you are going to read. Yes. So whatever filter condition you are going to add, based on that, it is going to connect with the particular partitions. So based on that, it is going to generate a billing for you. So instead of reading 10 TB data at a time, we are using partitioning, we are using compression, we are using columnar format to reduce data scanning so that we can reduce cost of Amazon data. Let's start in. In this session, as part of Master Amazon, let's start writing first Amazon Athena SQL query on CSV in AWS S3. Okay. So here, what I'm doing, I'm going to create one bucket. In that bucket, I'm going to create a file. In that file, a folder. In that folder, I'm going to place a file. Okay. Let me first open my datasets location. In my computer, in, in C drive, I have datasets folder. In this, I created one folder called Athena. In this, you can see website traffic file. Let me open this file. So this is input file. It contains user ID, timestamp, page URL, from where visitor is coming, and then country of visitor. Okay, this is my website traffic details file. So first I am going to create bucket, S3 bucket. So here I am going to create S3 bucket. Let's see, here create a bucket. Bucket name I am giving Sreenivasa, let's say AWS DE hyphen Sreenivasa, uh, let's say Sreenivas hyphen Athena. Athena. Then uncheck this option. I acknowledge. Then create a bucket. In this bucket, in this bucket, uh, in this bucket, let's create a folder called website underscore traffic. Let's create a folder called website underscore traffic. Create a folder. Okay. Then create folder. Inside this folder, place a file. You just go that folder location. Okay. Let's say this is mine and this is folder. Let's just drag this website traffic folder and place file. Okay, click on upload. Click on close. Click on close. You can see file is uploaded. Okay, first part S3 part is completed. S3 part is completed. Now, remember we can create metadata information using glue crawler, and the second one create a table. So we are going to see creating external table. Okay, so here see, I'm going to create a website traffic table, and whatever columns I'm seeing here, I provided column details. Column details. Let's take this one. Let's take this one. So going to query editor, and here see, if table is not existed, create a table. Okay, next one, and each column name data type, each column name data type, each column name data type. Next one, and my file contain column delimiter is comma. Every row separated with new row, new line. Yes or no? New line. So I am providing those details here. See here, row format Saturday. There is a predefined class in Athena called Open Saturday predefined class. This class is responsible to read this file and identifies this information. And I'm giving a class. This file contain comma separator, and this one contain header. We are providing header details, right? Then, while anyone executes select query, keep this header. Next one. This file is presented in S3 location in a text file format. Location of this file is, tell me, this is my file bucket name, AWS hyphen Sreenivas hyphen Athena. This is my file location. bucket location. Under that bucket, there is a folder called website underscore traffic properties. Properties. There is no encrypted format. Okay. I am providing this definition. Just create a table. And one more important part. One of our friend asked, do we need to create a bucket first? Sorry, database first. Yes, correct. Let's say you are working for project one. So for every project, we create a separate database. For every project, we create a separate database. So here, if you see, already I have created a database name Sreenivasa underscore DB. If it is not created, you have to create. Okay. So see, there is no table. There is no table website to traffic. Once you execute this one, you are going to see table. Now, if you observe here, run button is disabled. Run button is disabled. Why? If you remember in how Amazon Athena works, I added one point. Can anyone tell me? If anyone tell me that point? So once we execute Athena query, it is going to persist, right? Whether table is created or not, select query executed or not, how many records it returned, that kind of result, right? So see, we have to create a separate bucket for loss of Athena. Let's create a log, create a bucket. In this bucket, I'm giving AWS DE hyphen Sreenivas hyphen Athena hyphen logs. Okay, uncheck this one, then create a bucket. Okay, I acknowledge. Okay, create a bucket. Now go to Amazon Athena. Go to Amazon Athena. Scroll up. Scroll up. Here you can see edit settings, or you can see query settings. Click on edit settings. Click on edit settings. If it is not coming, let's go to query settings. Okay. So scroll down. Click on uh, okay. Go to saved queries, go to recent queries, editor, and once again click this editor, edit settings. Before you run, you need to set up this one. Click on edit. Okay. Query settings. Go to manage. Click on browse S3 and select our bucket. AWS Sreenivasa hyphen Athena hyphen Lux. Then click on choose. Click on save. That's it. Now you can go editor. You can select, see, run button is enabled. Select this query. Click on run. See, here it is going to, yeah, 1 minute. Execution error, returned code 1, and see DDL task, illegal exception, illegal character at this location. Okay, Amazon Athena. Go to here. Yeah, here. New line, right? Yeah, sorry. Let's select once again this query. Click on run button. You can see run query. The query is completed. You can see website underscore traffic table is created. Now I want to read this data. Now I want to run queries. Let's see, you can run any SQL query. Let's say select star from website underscore traffic, then select this query, control enter. See, you got complete records. You can apply any SQL query, on this table. Okay, clear writing, how to create a table, how to run queries, how to configure S3 log location for storing the results. Yeah. Let's starting. As part of Amazon Athena, in this session, let's see creating table for a Parquet file with compression and partitioning in Athena, then apply SQL queries. Okay. Let's observe the benefits of this approach, Steve. Yeah, first one, we are going to create a S3 bucket. In this S3 bucket, okay, in this S3, we are going to first create a bucket. Under bucket, we are going to create a folder. In this folder, we are going to create different partitions. Partition 1 and partition 2, partition 2. Okay, like that, we are going to create multiple partitions and so on. Partition N, partition N. In this partition, we are going to store file in the format Parquet file. That Parquet. We store file in the format Parquet plus this file we store in compression format. So what is the benefit we get in this way of storing the data? Let's say if I am using Athena query editor for for reading this data, so here we write SQL query. Earlier in same S3 bucket, we created a bucket, okay, and we created a folder. In this folder, we loaded complete files. File. So observe, if I execute SQL query, let's say select star from X table where year equal to let's say 2025, year equal to 2025, and month equal to 3, and uh, and day equal to 20. Let's say I want to this data. Assume here this file is 1 TB data. 1 TB data. Earlier, previous queries reads entire data. But here we did partition based on year, month, and day column. So let's say 2025 March day 20 contains just 1 GB data, 1 GB data, and that too compression format. Let's say compression is it converted, let's say MB's data, MB data. Then if you scan, how much data we are scanning? Just MB of data in a S3 location. Previous approaches, it's a TB data. So cost of your SQL query is high compared to this partitioning and compression. So same query only. We are not changing anything. We are applying same query on previous approach and current approach. Current approach reads only MB of data. Previous approach reads entire data. So in this way, we can improve performance of the application, Athena query, and save cost of your SQL query execution. Okay, yeah, let's implement this one thing. Let me, in this, let's see here, we are going to take a file, sample underscore data underscore snappy dot parquet. I have already did a compression format. Let me show file in my C drive under datasets, under Athena. Here you can see sample dot snappy dot parquet file. Using different approaches, I have converted this one. So I already shared this datasets to you. Go to S3 location. Okay, S3 location. Then here, let's see here, AWS Sreenivasa Athena. In this, what I'm doing, I am going to create a folder called Parquet. See, I am going to create a folder called Parquet. Create a folder. In this Parquet folder, I am going to create a subfolder called year year equal to 2024. Create a folder year equal to 2024. Then create inside this subfolder, create a folder for month equal to 004, month equal to 04. Create a folder. Okay. Then in that month folder, create a subfolder called day equal to 10. So this data is related to April 2024, April day 4 data. Okay. So let me open any online Parquet viewer, Parquet viewer online. Let's take any one Parquet viewer. Let me open a file under C drive, under datasets, under Athena. So this is my sample Parquet viewer file, Parquet file. See, you can see timestamp. In this timestamp, you can see 2024 and month is 04. In that month, we have day 10. All records are day 10 records. So I created a same style and I am going to upload data into in this location. Just take this file, and drag this file into this location. Okay, then click on upload. Click on close. Click on close. Okay, yeah. So in this bucket, we have this data. This is my bucket name. Okay, so let me give a bucket name. In this bucket, we have data. Okay, so this is my bucket name. In this bucket, we have the data. Yeah. So here, let me create a table for this. Okay, so I am creating a table analytical parquet. Let's first go to Athena. Okay, go to Athena. In Athena, I am creating a table. Table name is analytics underscore parquet. Column names are user ID, timestamp, action, platform, partitioned by year equal to int, month equal to int, day equal to int. Then stored as a Parquet format where it is presented in this location. And table properties are the file is in Parquet format and compression technique used is snappy. So while creating table, we are giving all these details to Athena. So there is no table analytics underscore Parquet. Let's click and run this one. You can see a table is going to create analyticals underscore partition, and you can see compared to other tables, here you can see extra is partitioned. This table is partitioned compared to all other tables. It is super fast and it reduces cost of your Athena SQL query. Okay, next one. Now I am writing SQL queries. I am writing SQL queries. Before doing any SQL query, we have to give a indication to Athena. Hey Athena, my bucket contain different partitions. Then understand what are partitions means subfolders. So here we given a column names, right? Partitioned by year, month, day, right? So it is going to check the subfolders inside a bucket and understand the partitions. So for that, we are giving indication to Athena say MSCK repair table analytical parquet. So when we apply this one, it checks our S3 location and understands the partitions details. Let's execute this one. Then it gets all the partitions information. See, year equal to 2024, month equal to 04, day equal to 04. Added partition to Metastore Analytics Parquet. Are you seeing this message? Yeah. Now you can write where condition or filter condition. Then this query directly goes to particular partition, reads the data instead of reading entire data. It is super fast. We are not seeing complete difference previous query, this query. But if you apply same thing for GBs of data, TBs of data, petabytes of data, you are going to see clear difference. What is the difference we can expect? One is faster execution. Second one is cost reduce. When you run SQL query, it instead of scanning TBs of data, it is scanning MBs of data. Because your data is compression format. Clear, right? How to create Parquet format, how to create a table with the Parquet format, with compression, with the partitioning. Okay. Yeah. Let me explain. Let me continue Master Amazon Athena. In this, we are going to see loading JSON data into Amazon Athena table. So we seen CSV format data, we seen Parquet format data. Now let's see. Now let's see load JSON data into Amazon Athena table, then write SQL queries. Okay, let's create a folder, JSON folder in our S3 bucket. So this is my bucket, AWS Sreenivas Athena. Create a folder. Folder name is JSON. And in this JSON, we are going to load a JSON file. So in my location, you can see sample underscore JSON, sample underscore nested underscore JSON. Let me open this file. See, so you can see different JSON records. I am going to load this JSON file. Click on upload, click on close, click on close. And then let me create a table in Amazon Athena to read JSON format data. If you remember, for CSV, we have a CSV SERD class. Similar way, for JSON, there is a predefined class, JSON SERD predefined class. Can anyone tell me how JSON data looks like? Anyone? Anyone having idea about JSON? It starts, a record starts with curly braces and ends with curly braces. Here we have key, comma, key colon, value. A key colon value pair separated with comma. Let's say comma. Another key value pair, key to colon value to, and so on and so on. In this way, JSON data is presented. This is for one record. Another record, comma, another record. JSON. So in this way, we can see different records. So there is a predefined class called JSON SERD. This class knows about this JSON data. So if you give your S3 location, then this JSON class is responsible to identify the structure of your data. Okay. Now I am creating a table called create external table user sessions with all column names. Then I am giving location of my S3 bucket JSON location. Let's create a table. So you are going to see user sessions table. Now I am writing I am writing SQL query. So we are getting particular record. Clear, right? How to create a table for JSON format data, and query, writing query is common, SQL query. Once a table is created, we can write SQL queries. Yeah. Let's continue master Amazon Athena. In this, let's continue. Next important topic is views in Amazon Athena. Any idea views? It may be DBMS, it may be data warehouse. What is the purpose of views? Usually, what is the purpose of views? Can anyone correct? We have a table with a table, a table with multiple columns, multiple columns, okay, and multiple rows, multiple multiple rows, multiple rows too. So we do not want to give complete access of this table. I want to create a window. I want to create a window. Example, in our home, instead of showing entire house, we will open a window. Then some part of house we can see through the window. Similar way, we can create a view, view 1, view 2, view 3, and view 4. Like that, we can create view n. In this, I can give some columns access, all rows. In this, I can give some columns, but few rows only. In this, I can create another view. I can give some columns and I give only some rows with some other conditions. So like that, we can create multiple views. This view I can give to analytic 1 team. This view I can give to analytic 2 view. This view I can give to analytic 3 view, analytic 3 team. So that if they query on this view, then they get data from this table. A view is a saved SQL query. Saved SQL query. You can query like a table. The downstream people, they do not know it is a view. They, sorry, Tim, 1 minute. Let's continue, Tim. So, so we will create a view to expose part of table data instead of giving complete table access. We will create different views and we will write different conditions, means SQL query. That SQL query internally going to talk with the table to get match records instead of exposing complete table data to everyone. We can create views. It is similar to same as RDBMS or data warehousing style team. There is no different. Okay, let's start creating a view. Let's say I have one data set called user events. in my uh, location. Let's say this is my user events. So I'm going to load this user events data into user events table. On that table, I am going to create a views. Let me uh, explain process. So first, I am going to create a table. I am going to create a table. Let's see. This is my bucket name. This is my bucket name. So let me create a bucket. Sorry, create a folder, views folder. And in this views folder, I'm going to upload a file, user events file. Let me upload this file, user events file. Then once we upload it, then go to uh, Amazon Athena query editor. Then first create a table. First create a table for it. So I am creating a table, user events table, to point to this folder. And this file format is CSV. So I am using CSV Seredy class to know about this input file format. Then I am giving path of my CSV file in external location called S3 location. So then I am writing select query on table. Select query on table. This select query gives complete rows and columns. So I do not want to give this complete rows and columns to everyone. Instead, I want to create a view. I want to create a view. I want to create a view. So create or replace view. View name is recently login and type is event type is login. So event type is login. I am creating view only for login people. Then a analytics team. This is a table or view. You can access and present these details to your report. Then I am executing this one. Then it is completed. Then downstream going to use this query to access the table. But backend it is connecting user events table. So we are backend team or downstream team going to execute this query. But this query internally going to communicate with whom? Actual table. So they are getting only who logged in, who used logged in. But we are not exposing all columns. We exposed only few columns. So whatever our downstream expecting, same format, we created a view, we given view to downstreams. So like this, you can create nested views for different conditions. Okay. So clear right now, what is view, how to create a view.